There we go.
Well, Tara, we had what, 65 or so people that has
62.
confirmed, right?
62.
62?
Yes, sir.
Well, that's pretty awesome.
Can't complain there.
No, not at all.
I think it's all because of Ron and Tara personally.
And Lisa.
And I really think it's because of the topics. There's some good topics on
There's
here
some great
today.
topics today.
Yeah.
Well, let's see. I know we're on a tight schedule, so it's 10:01. Why don't we go ahead and get started? Tara's already got it in the recording session mode, so that'll be awesome. The folks that aren't here right now, they can look at it at a later time. But hey, good morning, everyone. I'm Fred Diamond, Director of Facilities over at Citrus College, and we truly thank you for joining us this morning. We have some good topics for you, as Ron said. So before we get started, I know that Tim and the folks over at Trane are going to be coming up pretty soon at 10:10, and they've got a lot of information I want to share with you regarding all of the new stuff that's happening on the chiller side and energy efficiency and the transitioning of our energy agenda across the state, all kinds of good stuff. But I wanted to tell you about a couple things that are going to be coming out also. Most of you are quite aware of the new building code that is going to be coming out on January 1st. There's a number of changes in there. There is some really important stuff regarding Z&E requirements for EV charging, Z&E on the generation side if you're doing a building that's greater than 5,000 square feet, whole bunch of stuff. There's some upcoming information that will be coming out. I haven't actually seen it all yet regarding battery storage. There's a number of changes there. There will be an IR that's going to be issued by the Division of the State Architect. And for folks, I don't know if anybody does faculty housing, there is an assembly bill for that one that's on the docket at AB 306 if you want to do some, a little bit of homework on that one. Other things, just to give you some of the goings on that's happened over the last couple months, Ron and I and a number of other stakeholders have been having some conversations with DSA, in particular with Craig Rush down in San Diego. You're going to hear a little bit about that in our upcoming topic with grid systems. ALOC is going to give you a little bit of information on that. And for those of you that want to do battery storage, whether it's for resiliency on campus, or maybe it's incorporating it into a new building, maybe you have a bond program, there will be some major changes with that. And we will keep you informed as time goes on. As soon as the interpretation of regulations has been issued to the general public, we'll share that with you as well. We want to make sure that everybody is, we have an open book and everybody's up on the topic. And outside of that, again, I want to make sure that we thank you all for coming today. It's very important that we stay together as a group. And we're going to have a little discussion on that towards the end of the show today, regarding our transitioning of programs from the partnership over to the new HEAP program. So with all that being said, there's a bunch of stuff we have for you, and Alok will be joining us a little bit later. But for now, Tim, I know you're on board with the good folks over at Trane, and we're going to turn it over to you. Welcome aboard, and thanks for joining us today.
Well, thanks for having us, Fred. Tara, you have the slides prepared?
I have the slides and I'll share them right now.
Okay.
Oh, Tim, I was actually going to share so I can drive, if that's okay.
That's between you and Tara.
Tara, is that okay?
Yeah, you guys, if you want to do it, that's not a problem. Lisa and I were just on board in case you guys wanted it.
Perfect.
Okay.
Thank you.
All right. And I'll turn it over to John. Thanks, John.
You should have the controllers.
Yes, sharing now. Can everybody see my screen?
Yeah.
Yes, you're good.
Yes, I'm good. Okay, perfect.
Yes, I'm good.
There's something going on with this.
Yeah, I'm not sure what's happening here. You hear the feedback too?
Yeah, I do hear the feedback from your thing.
Give me 2 seconds. Let me see what I can do here.
technology.
It sounded otherworldly.
It
Yes.
did. How you doing, Linda?
Oh, great, Fred.
I like your photograph.
Hey now, 20 years ago, fabulous.
There you go.
Love the hair.
I know I'm a curls.
Seems to have stopped once maybe somebody else muted. John, if somehow it's something to do with your PC, I can also pull up and work the other direction. We'll see when you come back on. John does have more slides than I do, so that's why he was driving.
Hear me now?
Yes, that's much better.
Okay, I'm sorry about that.
No, you're good.
Awesome.
Had to switch headsets there.
We're still on board though. It's only 10:07, so you're good.
Okay. All right. Share this. So my name is John Schlunt. I'm a mechanical engineer located in Central California. Was invited here today to talk to you guys kind of about the electrification, decarbonization, kind of the trends going in that direction, also leading into some of the equipment solutions. Yeah, so I'm excited to be here. Thank you. We have Chan.
Yep, I'm here. My name is Chan Kim. I'm a system sales leader for Northern California. I'll be sharing about our overview of our product options.
And welcome. I am Scott Huffmaster, Director of Sales for North America for Trane Technologies. Thank you for allowing me to join as well.
Yeah, so what's good about having kind of a group of us in presenting something like this is that I have designed several projects that have been carbon neutral, decarbonization focused, also zero net energy. And what I find is it takes a team. There's no silver bullet coming into play. So it takes a group of engineers to come up with a good solution. And so we'll all be presenting a little something different today. So what we're going to cover is some key definitions, do a brief overview of the purpose, talk about some of the challenges, the path forward with design, technology solutions, some unique and new funding options, and then we'll close. So some key definitions: decarbonization is removing carbon-related greenhouse gases created through the burning of fossil fuels, whereas electrification is the conversion of machine and system power or heating to electric resources. The other thing you're going to hear about more and more is embodied carbon, and then carbon is associated with the materials that are innate to the building and also produced throughout the initial construction of the project. The key thing here is that decarbonization is the goal, whereas electrification is the solution. So you'll hear these words interchanged a lot, but that's really kind of the key is decarbonization. That's the goal we're shooting for. Electrification is the solution that we're using to get that goal. So purpose, and I'm starting high level here. Our population growth, the rate of the world is growing. We have a lot of emissions. We have global warming. We have lots of stuff going on. Our rate of growth from a population standpoint might be slowing, but our overall population volume is still growing. So this is a real problem that we have to address. And it was discussed at the 2015 Paris Agreement initially, which is where a lot of this stuff that we're talking about today comes from. So there was a discussion about limiting the global temperature rise by 2 degrees Celsius this century. What's unique about this Paris Agreement is that they left it up to the individual countries to come up with their solutions and then reevaluate those solutions every year. So that's what this graph is showing. What's been kind of interesting about this trend and kind of what came out of this is the countries were left up to figuring out how they do it. In our country, California, then, hey, let's accelerate that. And then actually community colleges, individual entities said, hey, let's even do better than that. So there's a lot of movement in this direction. California is kind of the leader in this regard, but it's moving quickly with the momentum it has behind it. So buildings impact. So there is a lot of carbon emissions associated, but a building has a big impact in that. So 40% of annual global emissions are created by new buildings. Of that, 27% are related to the operations of that building, and 13% is related to the embodied carbon. So we're going to focus today on the building operation side of it, but we really can't ignore the embodied carbon portion of it either. Existing buildings account for 2/3 of all buildings, will account for 2/3 of all buildings in 2040. So in that regard, we have to, a lot of what we focus on is new buildings, but as we're looking at these agreements, and we can do this technology, that technology to be able to offset the carbon emissions. But in reality, we have to address the existing built environment. Without doing so, we will not hit the goals of the Paris Agreement. So this is something that is kind of, this is probably one of our biggest challenges, addressing the existing built environment. There's also a lot of rising, as I've discussed, a lot of rising public interest in seeing us meet these goals. Everybody sees the carbon emissions, especially in California. We might see, directly related to the wildfires and such. So people are more keen to see what's going on, or more motivated to see improvement and change. Local AHJs are incentivizing. I've been seeing that a lot throughout the state. They're incentivizing decarbonization, or penalizing you if you don't, for compliance. But what I've seen more importantly is your own goals. So these are your goals stated by the CCC. And what I found most interesting about this is these are your goals, but at the same time, you have some leadership, some colleges that are even accelerating this. So, hey, let's have 100% of our new buildings and major renovations be zero net energy by 2030. That's the stated goal. Some I've seen that I've worked with that are saying, hey, let's do that by 2025, which is great. I think it's a great goal, but it brings some inherent challenges. There is a lot of challenges with technology. As we're shooting for these goals, technology is having to rapidly ramp up and develop. So that's been probably one of the biggest hurdles. California is leading the way in making these changes. So really started focusing on it in 2006, just as an experiment. 2016 renewed their interest. And then 2018, they led the global summit. 2019, we started to see our first code requirements for solar ready. But what's happened is previously in previous slides, I've talked about decarbonization as a goal. 2022, so the code that's changing here in a few weeks, this is the first time that we're seeing decarbonization as a requirement. So that's key for keeping this in mind. We are no longer in the goal phase. We are now in the requirement phase. What's more interesting, I think, is that by 2030, that's our stated goal. We have other goals in that, and we just reviewed this slide with the other goals. But we have 2 code cycles between now and then, and that's a typo. 2025 doesn't happen twice, but we do have 2 code cycles between now and then. So we're kind of in this logarithmic scale where things are going to start ramping up. And that ramp up has costs associated, has spatial constraints associated. So what does that mean? So the challenge, so that's kind of high level. Now we're going to talk into the challenge, some of the big challenges that I've seen on these projects. So some say that global warming is moving too fast for evolution to keep up. So meaning that things are, the problem with the world is too big for us to tackle, but we still got to do something. Others say California goals are too ambitious given current technology, or gas is the most efficient and cost-effective energy source. It really, I say that all these are true. I don't dispute any of them. We have to balance everything. And as engineers, I have to kind of come at this from multiple directions. So there's plenty of obstacles, but I also see this as plenty of opportunities. So there's some technologies that have some straightforward solutions. So gas pack units, your traditional gas pack electric units. We have heat pump package units, good alternative. Really no sweat off your back. Small capacity water heating, no problem. We have a heat pump water heater available. There's lots of them out there, or even electric resistance. No big deal. Variable refrigerant flow, which has been popularized in the last 10 years, it meets all the decarbonization goals, but it's not really applicable for all applications. So there's some give and take there as well. So trends. Community colleges, there's growing needs for labs. There's declining lecture halls. I've been doing more projects lately that are really focused on labs, less lecture halls, especially as we go more remote with the lecture halls. So what that does in a lab setting, from a hot water standpoint, now I need to provide large volumes of water, of hot water. They have to be available, they have to be there even just on standby mode for emergency situations. And then in kitchens, we have high temperature minimums. So these are two critical areas that technology is trying to address right now. There's a couple options out there, but not a whole lot of them. So now we're trying to see, hey, does that one solution fit for what we have, what we need? Or do we have to come at this with a separate approach? Instead of one central heating system, go with multiple heating systems throughout a building. Those are things that we have to consider. Then you have everyday hot water sourcing. So you have large hydronic boilers and systems having high temp requirements. So now we're going to replace that with maybe a heat pump chiller solution, air cooled or water cooled, and maybe the temperatures can't get up as high as your boilers once had. So that's something we need to evaluate, because that is a big challenge. Domestic water heating not having electric options without external tanks. So now you have a challenge of, hey, we had just a small little water heater. That's great. Well, now we have to have a water heater plus a tank. And so now we're having spatial constraint demands. So this is another big challenge. Really, the space is probably the biggest challenge that I see. So this is an example of one 2 million BTU boiler in the equivalent air-cooled chiller. So it has a limited upper temperature range. So it's not the end of the world. We can design around that. But the footprint is 6 times larger. It has to be outdoors, and it requires a whole lot more power. So this is kind of the mental model shift that we're having to experience and go through, because it's just a lot more space. How do we space plan around that? Especially if it's an existing campus, existing building, how do we integrate this into our solution? So another trend that you should all be very aware of and be asking your engineers to verify, finding a sustainable design with proven technology. There's manufacturers that are out there right now that say, hey, I have this technology. I have heat pump technology. We can work this for your application. What I'm seeing is their data that they're providing is revised a couple months later, even in the middle of design. And now all of a sudden, your once compliant and solid design is no longer going to work. And it's causing redesign. If not caught early, it could cause change orders down the line. So there's a lot of, I don't want to call it snake oil, because it's not snake oil. There's good technology out there, but it's developing quickly. So as the state is, and as we're pushing our goals up and trying to meet these demands, we just have to have both eyes wide open to make sure that we're going with a solution that can meet the requirements that is proven. Control complexity is increasing. So a boiler system might traditionally have just a little circ pump and a couple little set temperature sensors. Now we have a lot more controls involved, and lots of flow switches and flow sensors and pumps and everything else. So yeah, we're adding complexity to our systems that maybe weren't there once before. So path forward with design. So we do have options, and I have a couple examples to just discuss with you. But really what we're doing when we consider these a new project is we're optimizing the building envelope. We're maximizing energy efficiency. We're trying to recover waste energy. We're electrifying our loads, integrating controls, and then considering embodied carbon. So these are really the major things that we're looking at, especially early on in the project. So work with the architect, work with you all as owners to develop a plan to approach this project. So this is a project where we considered the building envelope early on, and we looked at a kind of a chimney effect to maximize our return air and our air transfer. which minimized our energy. We also maximized our energy efficiency by using a VRF solution. We recovered waste energy. We electrified all loads, including water heating. This is a lab building as well, to the classroom and lab building. And we had fully integrated controls throughout. So this is a decarbonized net zero building. And this unique project is a aquatics complex. And this one has a large water source. So we have to keep maintaining the temperature of this pool within 1 degree to maintain its performance for competition. And so we're having to offset the boilers with air-cooled chillers, which take up a whole lot of space, as I mentioned before. So that's a big change here. Fully integrated control. We electrified all the loads, so big electrical loads now. But what you result in is you have a big yard out here now, whereas you might have been able to put those boilers into the building before. So doable, yes, but there is some give and take. Another building, so this is a lab building. So building envelope and distribution was considered early on. Try to maximize our energy efficiency. This one had a combination of air-cooled chillers, VRF, and multiple heat pumps for the boiler system, because this lab could not accommodate one big central system. So we had to go with multiple systems distributed throughout. We electrified all loads and integrated the controls as well. So I can go into this stuff a lot. I know we're short on time, so I want to keep things moving along and switch it over to some technology solutions.
Thank you, John. Appreciate it. As John mentioned previously, over the last few years, decarb and electrification movement have been picking up steam. So during that time, we have been gathering information and feedback on challenges from individuals such as John to work on different products and system options. We'll give you a high-level overview of the products today and possible system option with a unique funding opportunity. Starting with our portfolio of what we call light commercial products, which includes heat pump package units and VRF systems. With our Precedent, Voyager, and Horizon lines that we increase our options, such as large tonnage options for heat pump package units to meet your needs. Right? Trane also formed a joint venture with Mitsubishi a few years ago to provide VRF solutions. We're able to integrate traditional HVAC systems into a heat pump operations utilizing the LEV kit to provide flexibility. Next slide, please. With the high temp hot water being another challenge, we came up with a high temp domestic heater solution utilizing the CO2 refrigerant. The outdoor unit looks very similar to the VRF systems, but instead of feeding the refrigerant into the building, we'll be providing hot water to the building. This system can provide up to 4.52 COP based on ambient conditions and can go up to 176 supply hot water. It can operate 100% heating capacity down to 36 ambient temperature and all the way down to -13 ambient temperature with associated D-rate along the way. Right? The system is modular, so it can be scalable to meet your heating needs. The system comes in a skid with associated heat exchangers, tanks, and pumps for ease of installation. The system will mostly be installed outdoors. However, it can be installed indoors with proper ventilations to provide design flexibilities. Next slide, please. Now we'll go into the chiller portfolio. I think it's important to understand different operation options. As you can see, there are 4 different options provided at the bottom. The first operation is cooling only. That's the traditional operation where everybody knows what chiller does. It provides cooling to the space, right? The second operation is chiller heat recovery. In this operation, chiller provides chill water as a primary function, then recovers as much heat as possible. It's considered simultaneous. However, heating is dependent on the cooling load. So if there isn't a cooling load, heating is not available, right? The third operation is heat pump operation, where the chiller utilizes the reversing valve to operate either cooling or heating. The circuit is reversible, so only the system can only handle or provide cooling or heating at one time. The multi-pipe operation is where you can do both. You can provide cooling and heating simultaneously, where you can control the set points for both cooling and heating at the same time. The associated model number that's represented here It's different product lines we have for different operations. Next slide, please. And here is our air-cooled chiller options with operations that I discussed previously. As you may have noticed, we are providing a couple different unit types where it's what we traditionally call a regular unit and a modular unit to give flexibility on the spatial constraints you may experience. That has been mentioned previously. Now I'll hand it over to Scott to discuss a possible system option with unique funding opportunities to offset costs of the decarb and electrification movement.
Thank you, Chan. So as you looked at the two different options that Chan just shared, one thing that you can see is we are looking to have some form of a source for heat transfer. Whether that source for heat transfer is the water source or an air source, you've got a place that you're moving heat from in an electrified system versus creating heat as you would if you were burning a fossil fuel. That's one of the key pieces to electrification. What I'm going to talk about now is a new way you might consider to look at it. It might be a way you've looked at things in the past, and that is the utilization of thermal storage. And so, John, if we'll go to the next slide, I am going to talk about something many of you probably haven't seen. And this is the concept of using thermal storage to not only cool your facility, which many of you may have worked with or have seen over time, but what if we can use thermal energy storage as a way to also heat our facility? So what we're showing here is a system that we call our storage source heat pump system that allows us a way to either heat our building, cool our building, or simultaneously heat and cool by having a source for heat transfer. And that source for heat transfer is that thermal energy storage, okay? And if we have excess heat transfer that needs to occur, that's going to occur outdoors. So that can occur, if you look at the top right, through our air to water heat pump, or optionally, we could be using a cooling tower to exhaust heat out of a building. So let me hit some key ideas on how this system operates now that we've seen what it looks like. So as with other electrified systems, outdoor air is that primary source of building cooling and heating. So when we need to have excess transfer of heat, we're usually using outdoor air as that source. The cooling tower provide the ability for supplemental cooling and again, heat rejection if that's needed. The thermal storage battery now provides a way to balance the heat flow of the equipment and loads. And so you're able to store and utilize those things for later. The air to water heat pump then can also look at seasonality and is able to cool charge when you're in a cooling dominant time of the year. So in the summertime, we can make ice at night, freeze water, and then we can use that and melt that during the day when it's optimal for either your energy rates or building operation. The other piece here that the air water heat pump can do that is, again, a little bit different way to think is if you're in the heating dominant time of the year. So it's winter time and you're heating dominant and you're looking at using that thermal battery to actually heat your building. So when you build ice, you're heating your building. You can intentionally melt that ice. And so you can look at when your conditions are optimal to intentionally melt the ice and move the heat from outdoors in the wintertime. When is that going to be optimal? Well, that's going to be optimal when it's the warmest temperature outside possible. So you may run that air to water heat pump when it gets up to 45 degrees outside in the winter versus those cool mornings where it might be 35 or 25. Again, less lift means less work, which is a more efficient system, okay? And the other piece to this is we're able to melt ice with much colder temperatures. So instead of the efficiencies you see out of an air source heat pump, making 110, 120 degree hot water in the wintertime with cold outside air, all we need to make is 60 degree water or something in that range to melt that ice because, of course, ice is below 32. So you can heat charge and intentionally melt ice when the conditions are favorable in the wintertime. So again, what this is allowing us to do is to directly cool the building and shift electrical load, demand limit, also allowing us a way to store building heat during heating season. And I will add one last little comment. We are seeing these systems gain a lot of interest in cold climates. Now, many of you may not have to deal with designs below 0 degrees Fahrenheit, but we're actually looking at systems like this in Canada, in Minneapolis, in Boston, in New York, because we're no longer as limited through the lift and the capabilities of our equipment to do heating with air source heat pumps, because now we're actually using a source that can operate when it's cold out. So that's key system operation. Let me show you why we're bringing that up today. So if we'll go to the next slide. Typically, when you hear about a system that is more complex, and what I just showed you here, what we showed, the storage source heat pump, you would expect that that may cost you more. What we're showing here is an energy analysis that was done as part of an engineer's newsletter that Trane produces to help to train our industry. This is an analysis done for an office building in Chicago, Illinois. I understand I'm talking to people in California, but again, this is content you could go see on the web if you'd like. In this analysis, what we found is that a traditional chiller with gas heat or a chiller with electric heat would be a first cost savings. Thus why we show a first cost premium to go to the storage source heat pump system. The other thing we found is that the chiller with heat pump, what we're talking about for electrification, actually cost more first cost than this storage source heat pump system. So it's actually lower first cost than just going straight up heat pump. Here's the shift and why we're talking about new incentives. Now that we have the Inflation Reduction Act that has been passed on August 16th of 2022, the Inflation Reduction Act has provided access to a new incentive for us. It's not a new incentive overall. I'll get into details here shortly, but it's called the Investment Tax Credit under Section 48 of Code. With that, and with this analysis, we looked at, and we believe we could pursue a 40% tax credit for both taxable and non-taxable, public and private entities. And when we added that to our analysis, we found that the first cost premium for this system was near cost neutral. We also know that the energy cost was lower. And the next thing that we found, which was really exciting, was the emissions to this system were the lowest carbon footprint system that we analyzed. Now, could somebody find a geothermal solution with specific units that might have a lower carbon footprint? I'm sure that it's possible. But what I'm communicating here is in our analysis of 4 common system designs, the storage source heat pump system showed the lowest carbon footprint of any system we analyzed. Next up, the other piece, and you heard this earlier from John, that concern about the space required for an air source heat pump is 6 times the amount of space required for that boiler. When you look at these systems, when you just design on air source heat pump, you may need a lot of these pieces of equipment across a roof or next to your building or wherever you locate it. With our solution doing storage source, we were able to see a 50% reduction in the number of air source heat pumps needed, which means a reduction in footprint. But now we got to find space for these thermal energy tanks. So you got some footprint considerations there inside your building, less footprint needed on the roof. All right, if we'll move to the next slide, I'm going to answer the question you might ask. Hey, you're talking about things on a grid that's not as clean as our grid here in California. Well, what we're showing here is a comparison of one of the dirtier grids in Chicago to what is the cleanest grid as of 2020 available in the United States, and that's in upstate New York. What I will point out is you can see that consistent number. How much carbon footprint you have from a gas heating system is the exact same. We held that as constant. We didn't play a bunch of games with climates and this and that. It's, what's the heating footprint? And if I'm burning natural gas, it's going to be the same in both. What we looked at is what is the carbon impact when I go from a dirtier grid to a clean grid? And what you'll notice is, of course, the carbon footprint drops on a cleaner grid. But the other thing you'll see that's consistent is it doesn't matter which grid we do this system on. The lowest carbon footprint solution that we found in our analysis was storage source heat pump. All right, so I talked about how incentives play into this. Decarb and federal stimulus are 2 things that have now come together. You've been dealing with this in California and the push for this, but now it's happening at a federal level. Inflation Reduction Act, I hit that a moment ago. What is the goal for this? What is being targeted? Here you're seeing what came out from the US Department of Energy, what came out from the White House. The target, and one of the things that was meant to be addressed in this legislation, is a 40% reduction in greenhouse gas emissions from the entire United States by 2030. That is considerable. You heard earlier from John that 40% of our emissions comes from our buildings, right? And so if I'm going to remove 40% from the United States and buildings do 40% of it, we have to address not just new construction, but also the built environment. And guess what? You can't do that without money to do it. So if we'll go to the next slide, what I want to call out is there is a tremendous amount of dollars in this bill to address, but the one that gets missed the most, that 30.5 billion, the 30 billion, the 3.4 billion, the $1 billion for grants, the 50 million for air pollution in schools, all of those numbers are specifically called out in the bill. You can look up the numbers. What is not specifically called out is how much incentive is out there to focus on tax incentives for the commercial industry. And the Congressional Budget Office estimated the incentive values of the tax incentives in this bill to be at $216 billion. So the biggest piece of this bill is in tax incentives. So I know many of you don't have tax exposure directly. So let me talk about how these tax incentives can matter for community colleges. There are two areas that I'm going to focus on today. The first one you may be familiar with, it is called the 179D Energy Efficient Commercial Buildings Tax Deduction. Okay. And what's the update to this? Well, this has been around for a while. Historically, this was up to $1.88 a square foot before the passing of the Inflation Reduction Act. It was available for building owners as non-taxable entities. You may have chosen to allocate that deduction, okay? And that was the way that these projects happened. So you had interesting financial structures, you had leaseback structures of ways to go and capture these dollars. So what has changed? First off, the value of this has gone up. We've gone from $1.88 a square foot to as much as $5 per square foot, okay? Also, the way that this gets allocated has changed slightly. This is available both for private and public, but for a non-tax or tax exempt entity, you now can allocate, but you must allocate to the person primarily responsible with designing the property, okay? So these dollars will go to your MEP engineer, your ESCO you're working with, your architect. It won't go to your construction manager unless that's an ESCO. The other piece of getting to $5 a square foot, there are some requirements. If you look at on the left, you see base deduction goes from 50 cents to $1, bonus goes from $2.50 to $5. There are requirements for apprenticeship because we want to train our next generations. And there's a requirement for prevailing wage. If you meet apprenticeship and prevailing wage and you have to meet them both, you get a 5x multiplier. That's what takes the base deduction to the bonus deduction. So assume you meet those two things. The next part is the efficiency gain over baseline. And what's your baseline? Okay, if your building is new construction or less than 5 years old, then your baseline is your latest version of ASHRAE 90.1 that is in code. And if you don't have a recent code, then you must start with ASHRAE 90.1 2007. If you have something newer in code where you're located, you follow your most recent code. That's your baseline. Your improvement can either be energy units or energy cost. So part of talking about thermal energy storage again is that can reduce energy cost, even though it may not reduce energy units. I want to add one more provision that was brought up, which is an alternate deduction for energy efficient retrofits. So we talk about the existing built environment. If your building is at least 5 years of age, your baseline can be your current energy use efficiency. So your baseline can be actually be easier on your older buildings that have a larger carbon footprint. There, you're going to have to compare to that baseline and show that out. And then post energy project, you have to collect 1 year of data to do a comparison to show that and prove that you created that increase. So again, a lot more coming in this tax deduction. All right, with that, I'm going to move to the tax credit. Can these two things be done together? Yes, but it requires accounting to be separated. The 48 ITC is a tax credit, okay, that can go against energy property. And energy property historically included solar, fuel cells, microturbines, geothermal, combined heat power. There's an entire schedule that had been in place for what you could pursue there. So many of you, if you've done solar, are familiar with this. Before passage of the IRA, this was phasing down to 24% tax credit. It had been 30 at one point. Some key changes to this. This has now gone to a different ramp. We now start at 6%, and then we can get an additional 2% if we meet domestic content. This is not Buy American, this is domestic content, and there's some specific call outs there. You'll get a copy of this. You can look up the details of the bill. And then another 2% for energy communities. Now, the energy communities, for the most part, are likely not going to reside in California. There's call outs there for decommissioning of a coal burning power plant. So, more likely you're going to see this in other areas of the country. So let's assume you're getting 6 plus 2 at 8%, right? 6 for the base, 2% for the domestic content. That same 5x multiplier under 179D also applies under 48 ITC, where we can get that 5x multiplier, take 6 up to 30, take 8 up to 40 by following the apprenticeship and prevailing wage requirement. So this is a change that applies for these projects. The next big change is this was now expanded to include thermal energy storage property, defined as a system, which is directly connected to your HVAC system, which removes heat from or adds heat to a storage medium for subsequent use, and which provides energy for the cooling or heating of the interior of a residential or commercial building. Okay, so now what we showed earlier, that storage source heat pump system, the entire system designed properly can qualify for this tax credit. So if you're talking about, a $10 million project with thermal energy storage, 40% tax credit, that's $4 million available for both private and non-taxable entities. And for non-taxable entities, you can go for a direct pay option to get those dollars provided directly to you. So for that reason, we wanted to talk a little bit about storage today. So I'm going to end up with some of the key pieces of why we brought this into this discussion. Thermal energy storage and why this is included provides that demand flexibility, and that energy recovery can also reduce some of the pressure on your grid. So when you're seeing peaking, that thermal energy storage takes us from having to use electricity on a compressor and instead use electricity on just a pump to move heat around. Also enables renewable energy and decarbonization through maximizing when we buy off a grid. So if you historically know how your grid is performing, you can buy off the grid when you're seeing the most amount of renewables. Offers this redundancy, right? If a piece of equipment goes down, but you have an ice tank in place, for instance, you've got cooling already built for you, whether or not your compressor is running. And like I said, last but not least, that incentive has really changed the game on the interest in this system. So I'll summarize here the overall presentation, and then we'll be open for questions. Here at Trane, and likely with you, we're seeing decarbonization initiatives grow exponentially. I'm having presentations on this 5 to 10 times a week. I mean, the interest is huge. We know that reducing carbon emissions is going to change our thinking, change how we design our systems, change how we decide what systems make sense for our building. For us here at Trane, we're putting huge investments into growing our offerings for electrification, heating, teaching our people how to design heating systems, not just cooling systems, how to design energy recovery. And the last but not least, with this recent legislation, the Inflation Reduction Act, there's now unique opportunities to really rethink the inclusion of things like thermal energy storage into our designs. All right, I will say thank you for listening to our presentation. And I believe now, Chan, we're going to open up for Q&A.
Yeah, so there's a couple questions on the chat here. The first question was, for a campus district system, doesn't necessarily require TES to be entirely electric. I think I can take that on a little bit, and then I'll hand it off to you, Scott. I think my point of view is that, is it required? It all depends on your situation, right? So are you trying to get, is it depending on the cost? Is it depending on the system you have? TES is an option that we can provide for you right now, but there's other, I think, depending on what you have and what the situation is currently, there's different solutions for it. So I don't know if this is necessarily required, but it is an option. Scott, is there anything else you want to add to that?
I would add to that, thermal energy storage is not a requirement whatsoever to provide electrification. So I don't want there to be confusion there. In order to access the 48 investment tax credit, you do need to include thermal energy storage or geothermal. If you don't utilize one of those two systems, then you are not able to pursue that tax credit. The tax deduction for energy efficiency can apply to almost any system we talked about today, but the tax credit requires the utilization of either thermal energy storage or geothermal.
Okay. And the second question is, do you have specific heat pump or pool applications? And do we know if the IRA will work on the type of project too? So I think first question, I think it's two-part question. So first part question about heat pump specific to pool. I think there was an example, John, you had about your pool application.
Yeah,
so maybe you can.
Yeah, so I'm doing one right now actually, and the air-cooled heat pump that I'm designing for a pool application is not specific for the pool. So we're not running the pool water itself through the chiller or heat pump, but what we are doing is running it through a heat exchanger. So there is some loss there, but this is actually a common approach. So we're going to do this for pools. We have to do this for domestic water as well. It has to do with sanitation, has to do with preserving the coils and so forth.
Okay. And Scott, I think the answer may be possibly the same as previously, but do we know if the IRA will work on this type of projects too?
So there is an exclusion in IRA specific to thermal energy storage and having the pool itself be the thermal energy storage. So what they're trying to call out is you can't claim the swimming pool or the building itself to be your storage, because of course you could look at it in such a way that I'm going to overheat or overcool my pool. Well, the same way that a large water storage tank is being heated and cooled, you could do the same thing with a pool, but there is an exclusion call out specifically around that. That exclusion is not to say we can't use thermal energy storage to heat or cool a pool itself. It just means you can't use the pool as the energy storage.
Okay. And those are the two questions I had on the chat. Are there any other questions?
Scott, this is Fred over at Citrus. Real quick on the TES side, a number of our campuses have thermal energy storage already. Some of us have ice, some of us have chilled water. Which one do you prefer from the engineering side in thinking about space availability?
So it depends on system size and space that really plays into that. What I would tell you is small systems are more often ice, okay? Large systems are more often water. And then the in-between is where we have a crossover. That's not to say we haven't done systems with 400 ice tanks. You know, we could show University of Arizona that's done one of the largest ice tank systems that I've ever seen in person. So you can do larger, and yes, you could do a small water tank, but as a general answer, that's what we are seeing. From a system and application standpoint, we, as the owner of CalMac, did start our design around electrification in conjunction with the thermal battery with ice, because again, we own that product. That does not mean we're not doing analysis on how we could use a stratified tank to also provide heating and cooling and use that as a source medium the same way you might use a ground well as a source medium. We are going to do that analysis. I don't have that analysis completed, but we are working on that now. We've just already done the other work, like I mentioned, on utilizing an ice tank. The concept is similar though.
So many of us also have under our purview all of the maintenance side.
Mm-hmm.
So out of those two systems, ice versus chilled water, which one do you see less engineered obsolescence in? So which one is easier to maintain?
what I hear, and I'd like John to provide some comments here too. What I am told most often is that an ice system tends to be a bit easier to maintain. Now, I hear that more often in climates where a glycol makeup feeder into your chill water was going to exist anyway. So if I was going to have glycol to my air-cooled chiller anyway, adding ice tanks is not a big deal for me, right? In climates where you maybe don't ever use glycol, you might hear people argue that dealing with the glycol is more painful than dealing with maintaining that stratified tank. So, I think it also depends on, what you have to design into your system. I would like John maybe to provide some feedback and what you've heard from owners as well on that.
No, you're right. I think one of the biggest maintenance challenges of thermal storage is the pipes that are within them leaking. And so now you have to address that. And now you have to decommission the system, drain it. You have a mixture of solutions. It's all waste. So if you have your glycol in the system or whatever is going on, it could be a big challenge. So yeah, so you're absolutely right, Scott. But that's usually the biggest maintenance concern that I see is the integrity of the pipes that are within the system.
Yep, that's a great point. I would tell you that came up on a call this morning. We recently were awarded a project because of that, where the move was from a water storage tank to ice tanks for an NHL project up in Canada, where the maintenance of this entire water tank was much more painful than having a single ice tank that they might need to maintain. And so it became, the redundancy of, 20 different things and one thing could be valved off versus one large thing that might have to be emptied.
So there's another question that came up. So is designing an all electric system, campus heating, cooling system in California, mild climate much easier than in other parts of the country or not that much? So I can answer that by saying yes. So what happens when we get below, it's usually it depends on the manufacturer, but between, mid 20s, low 30s. Once we start driving that temperature down, the ambient temperature, we start to lose the effectiveness of the heat pump. And so we have to derate it. Additionally, now we have to start thinking about ice buildup on the coils. So now we have to do supplemental heating, strip heating onto those coils so that we can make sure that we're not freezing over the system and then having to stop the system altogether. So yeah, in the mild climates, this becomes a big challenge. So that's one thing that we are fortunate enough to have in California is not too many of those mild climates.
Agree wholeheartedly.
Well, you guys have done a wonderful job, Tim, John, Shannon, Scott. We really thank you. And do we have any more questions out there for the group?
Yeah, hi, this is Nat from Los Rios. I have a question. On the one example of the pool, did you consider as a supplement using solar hot water?
Yes, solar.
Go ahead.
Oh yeah. So solar hot water was considered. So the code is interesting. The code, previous code, so current code for another couple of weeks, 2019, actually limited what we can do with electric resistance, electric heat pump. So we had to supplement electric with solar, but that has now gone away. So now we can offset with electric as long as we have some kind of solar on the site. So that was the consideration for that project. Also, roof space, et cetera, is always a concern. It's always a premium as well. But yeah, it is a common solution, especially for smaller systems, to do some kind of solar heating in conjunction with whatever solution we're considering.
Okay. Second question is, prior to the new tax credit from the new bill, if you did a project where you're trying to go all electric for a central plant, the cost was extremely high versus the typical chiller boiler, or even the in-between where you're doing heat pump and heat recovery. We got a cost estimate for something like that, and it was extremely high. I don't know, and maybe this is a question, to get the tax credit, is there timing of let's say you've already made a decision, but now your project is eligible, does it have to start at a certain time, or is it like pretty much anything that starts after 2023, you can go back and get?
So, John, if you don't mind, if we go back to the slides, or I could throw it up real quick. The thermal energy project timeframe requires the project to break ground after really whatever that math is, 3 weeks from now. So the window in the bill starts January 1st of 2023, and it continues for 2 years for the start of the project. And the IRS just gave guidance on how that's defined, and it's basically if you've incurred 5% of the cost of the project, then that is determined as project starting. Okay. It does not mean you have to complete it, just to start it.
Okay.
If you start your project after December 31st of 2024, it does not mean thermal energy storage goes away. It changes into what's called CEITC, which is Clean Energy Investment Tax Credit. And that then has a net zero requirement. And so what we're going to see there is projects that combine solar, wind, or other things that achieve net zero with thermal energy storage together in order to qualify.
Scott, you mentioned something that if the TES portion opens up more opportunities, what if you are doing a project where you have heat recovery, you've reduced your planned greenhouse gas emissions compared to a standard central plant?
Mm-hmm.
Are there still options available without TES in terms of getting some tax relief?
Not for the 48 investment tax credit. That's the tax credit.
Okay.
Any project that you do that shows efficiency gain can potentially apply for the tax deduction under 179D. And thank you, John, for jumping us directly there. So you can still pursue a tax deduction for energy efficiency. And again, the value of this deduction went from $1.88 a square foot to $5 a square foot. So there's more incentive there.
Mm-hmm.
But to get the tax credit, you must include either thermal energy storage or geothermal.
Wow. Okay. Thank you.
Yes.
Hey guys, sorry, I had to jump off camera because I'm having network issues, but there's a couple other questions on the chat. First question is, I think we answered this, but we'll do it again. Does the IRA apply to the heat pump technology only, or only if we have TES included in it? And then if so, are pools and our IRA application also limited there too? So Scott, you want to go over the pool application one more time?
Yeah, I think I hit that question and I answered in the chat as well, but specific to pools, what it states is you cannot use the pool as the source for heat storage. So you can't go and spend $5 million on a pool and then get, $2 million of that as tax credit and call it your thermal energy storage. That's what they're saying.
Okay. And then next question, John, you may be able to answer. It's kind of tying to the question about providing heating, cooling systems in California's mild temperature. Cody mentioned, what about those of us in the desert? 27 low today, 55 high.
Yeah, so in the desert, that's still, so 27 low, that's still, I'm not too concerned about that. I've actually done some, heat pump applications up in the Sierras as well, which they get below zero. What you have to consider though is the D rate. And so at 20%, kind of that 27-degree low today, that's when your equipment starts to derate. It doesn't mean it goes from 100% to 0%. That just means that, hey, at 27 degrees, your system might be able to perform at that time at 95% of its capacity, 85% of its capacity. And then it kind of just trickles down the colder you get.
John, what are the ambient tolerances without a strip heater?
It's usually right around that 30-degree mark. So, and it depends on the technology. So some of these units are coming out with technology. Some different manufacturers have different solutions to where they can do simultaneous heating and cooling to be able to stage their compressors accordingly. So yeah, so there is options, but they are climate specific. So one solution does not fit all. I think that's why it's really good to see, you know, in this example, Trane, they have 8 different solutions for one application. So.
Well, folks, we're at the end of our time with the good folks over at Trane. You guys have done an incredible job, and I suspect that we'll be asking you to come back and maybe give us a secondary presentation if you don't mind. There have been a lot of comments, and I know that folks are going to have a lot more questions in the future. So for those that have some more questions, keep them in your docket, save them, and we'll produce them over for Trane at another time. With all that being said, again, guys, thank you so much for joining us today. We really appreciate it. It was very, very valuable information, and we all have a lot of challenges coming up for us all. Thank you again for your time.
Thank you, Fred, and thank you, John, for bringing me on here.
No problem. Thank you, guys. Take care.
Thank you.
Folks.
Appreciate it.
With all that being said, we're going to ask Alok to come on board, and he has some great information for us regarding grid systems, battery, resiliency, all that kind of stuff that will be coming up. Alok, we'll turn it over to you.
I think we're having some issues with the speaking again.
You're not able to hear me. No.
Look, I think we're having some audio communication with your, it's a problem.
Might want to reboot it.
Not any better if you're, that's what you're asking.
You may want to dial in a look.
Yeah.
Folks, thank you for your patience while he's, here we go, trying to get that resolved.
Well, Fred, I think we've got a great turnout today. I'm seeing like 68 people on here at certain times. So I think it kind of fluctuates a little bit, but wow, this is a great audience to have for this type of presentation.
It is, and this one's gonna, like I said, it's gonna extend into the future because this is a big deal, very, very complicated, and I know that folks are gonna have more questions in the future.
Right. And I know we got the California Energy Commission coming up, and I see those big B numbers coming up, you know, and I really like to have them maybe have a little conversation about that as well for what that means to California.
This is Joanne. I might suggest that you all come up with a workshop, whatever, at the next ACBO meetings, because when you start in talking about free money and tax deductions and getting that back, etc., you do get the attention of the CBOs.
Good point.
Not that I'm a material girl or anything.
They love that free money though, don't they, Joanne?
Oh, yeah. Oh, yeah, free money. I like free money.
And it's not monopoly money.
No.
Or gig currency.
Yeah. As long as it's not issued by FTX. And that is entirely true.
No kidding, Harrison. That's awesome. Good point.
While we're waiting, it did pop into my head. Do TES systems end up with any byproducts that are hazardous materials?
Not that I'm aware of.
Yeah, not that I'm aware. This is Chan just jumping in here. Not that I'm aware of either.
Yeah, this is Nat. If you have a TES for water, chilled water, there's nothing because it's just the same chilled water that's in your chillers and your pipe. Ice is a different story.
Considering it as a closed loop, I mean, if there was a leak from, a coolant line or something like that, then that's a different story. But on the water side, the answer would be no.
Right.
Yeah.
Many years ago at COD, College of the Desert, we put in a closed loop system in our central plant that was a blow down towers, and we used ice to chill down the system, the water temperature and everything. But it just seems like there's I'm talking 1990 type thing. But it seems to me like vaguely there was some type of chemical that we added to it. With all that heat we had in the desert, it wasn't exactly easy to make ice.
Understood. Fred, I can take that as an action item to get some more information and provide it to you.
That'd be awesome.
Okay.
I'm back. Can you guys hear me now?
Oh, you sound awesome.
All right, thank you. I'm not sure what happened, but we're here. And let me share my screen and you tell me if you can see it.
Perfect.
You're good.
Perfect. Okay, my name is Alok Singhania. I'm a partner at a company called Gridscape. My information is here in case you need to get hold of me, and I'm sure Fred can provide that. And I'm really talking about today what's called the microgrids, but if you want to really think about it, they're really local sustainable power plant that essentially will run your college campus. That's the whole idea behind it. And so the first question you might ask is, why do we care about all of that? Again, a couple of basic slides. This slide is slightly old, but what it was really saying is that our projected electricity demand is going to continue to increase at a substantial rate, especially if we're going to do the transition that previous callers talked about from fossil fuel to electricity-based systems. And again, slightly older slide. The EV sales are going through the roof. There is a whole bunch of regulations that says the trucks will also have to be moved to electric by 2025. And all it means is that electricity demand is going to continue to increase at a rapid rate, at least in California, if not in the United States. And of course, you're all familiar with PSPS events that's putting strain on resiliency, whether you have power all the time that you need or not. And if you combine all of that, essentially what it really means is that we have a little bit of a problem in our grid. And that's primarily because our grid is still fairly old style. It's a relatively one-way flow. You have a whole bunch of power plants all over, and you have transmission lines and distribution lines, and that's how you're getting your electricity for most part. But as we know, that itself, if we continue with that model, that's going to be very, very difficult to meet the demands. Central power plants are very expensive to build, and then on top, we cannot build enough of them properly because the cost is going to be really high. So a new model is really a distributed power system. A lot of you are also familiar with it. Essentially, what it means is that you can generate power anywhere and you can use power anywhere. And that's really is a distributed system. And we have a lot of experience with distributed systems. If you really think about it, computers went through distributed systems from mainframe to where we are today. The telecom companies went through from a more of a centralized system to a distributed system today. So we have a lot of experience in how to transition from sort of a centralized system to a distribution system. And one of the reasons why we can do that in the energy side is for the last 10, 15 years, we now have the ability to produce energy at local sites. We did not have that in a more efficient manner, in a cost-effective manner. Now that we can do that, it becomes easier to have power source generation anywhere you want, and then combine it in some unique way to redo the grid. And so essentially, the point ultimately is that electricity demand is going to continue to go up. Grid resiliency is going to become a challenge because of all the climate changes. We have all sorts of emission standards that we're trying to do for eliminating fossil fuel. And if you do all of that, the only way to meet that demand would be to adapt distributed energy resources or local power plants, we're calling it. And other big advantage of that is you do not have a single point of failure, primarily because now your power is generated a bunch of places, thousands of places, maybe even millions of places. And therefore you do not depend on a single power plant or single distribution line or transmission line. And depending on how the technology is used, I can see a time when we literally have millions of these distributed energy resources throughout the state connected in a very unique way. So if you have one part of the state that cannot get energy because the central power plant is down, it can come from somewhere else. So there are lots of very, very interesting things that are happening in the stage in the distributed energy resources. So what does it mean for a college campus from that perspective? So I call that renewable microgrids or local power plant. So what is the need for it? Again, here it says business case for critical facilities and emergency shelters, but it really applies to anyone, including college campuses. So essentially what it really is at a high level, you have a need for making sure that you have power available all the time. You have a need to make sure that your power is cost effective. You have a need to make sure that the power is clean power. And if you take all of those into account, then the solution is to really try to figure out how you can adapt a renewable energy microgrids for your local need. Now, we're talking here about solar, but there is really nothing in the technology that says that you cannot have solar, you cannot have wind, or you cannot have geothermal, or you can combine them in some unique way to do all of these things. The ultimately goal is that can I meet my requirements for my electricity needs by producing energy locally? And can I use energy storage in a unique way so that when the renewable energy is not available all the time, I still have access to that renewable energy? And that's really is the point in all of these renewable energy microgrids that we talk about. So again, in general, when these microgrids are running, let's say you have a college campus, you have a whole bunch of building and you're putting some solar. In some cases, you might even have wind power, and maybe in future you'll have geothermal, and you combine all of them, and now you're meeting a large percentage of your needs, power needs through these locally generated power source, and you have a storage system, primarily because these renewable energy don't always, they don't produce energy on demand. For example, solar you'll have during the daytime, wind you may have in the evening time, and therefore you have to have some way to store these energy. And once you have that, then the entire goal of the microgrid is to reduce your cost of energy. Make sure that you are maximizing usage of whatever energy that you're producing, and you are reducing your total cost. And on top of that, you are able to use the power of that energy if for some reason power is out, whether it's through PSPS events, or you have a storm, or you have an earthquake, or any of those kinds of incidences that you can use these microgrids to run your site. And again, I'm simplifying all of these just as a high level to kind of give you a concept of what it means to have a microgrid, what are sort of a high level benefits, and what are sort of the key components of that. Just again, I want to reiterate there that a local sustainable power plant has really 3 or 4 components to it. The first component is a renewable energy power source, again, solar, wind, geothermal, or any other kinds of power source. You got to have energy storage system. Currently, there are lithium-ion batteries, but maybe in future, we will have some other types of storage, primarily because these renewable energy power sources do not generate energy on demand. So what you want to do is whatever energy you are using, and if there's excess, you can store them into your energy storage. And you got to have a control system and software system that can effectively manage all of these things. And that's what's really what a microgrid is. And once you have that, as far as you're concerned, it doesn't matter whether you're getting the power from microgrid or you're getting the power in case microgrid doesn't have anything left in it from the grid or some combination of that, your system should run just as is. So this system really strictly is an add-on system that shouldn't affect any of your operations anywhere. And that's the idea. So what is Gridscape? Gridscape's entire business, entire mission is to really help this energy transition, to become more sustainable. And as we know that there is a lot of effort going on as we move from fossil fuel to an electric future. And this is where Gridscape's products and technologies can help do that. We've been around since 2013. We're based here in Silicon Valley. We have global presence, and we primarily have built these technology through many, many CC grants, as you can see them here. The very first one that we did was about 5-6 years ago, was 3 microgrids for Fremont fire stations. And since then we have done, or we are in the process of doing at least 30 to 35 of these renewable energy microgrids in California. This is a quick snapshot of what we're doing in terms of microgrids. We're doing 8 microgrids for City of San Diego. These are, again, the reason why I mention all of this is because it kind of gives you an idea of where microgrids can be used. These are smaller sites ranging from fire stations to police stations to community centers, and there are 8 of them. We're doing a campus-wide microgrid for Chabot College here in Hayward. They had an existing solar canopy of little over 1 megawatt, and we're putting a 3 megawatt hour microgrid battery storage system to take advantage of some of the energy that's produced by the solar, as well as to provide resiliency. We're also doing a campus-wide microgrid for San Jose City College. And I have a little bit more slides at the end, the next couple of slides to give you a little bit more details. And again, we're doing something very similar for City of Fontana. We just finished a community microgrid for San Pasqual Bando Mission Tribe in San Diego. This is again connecting several buildings and running their entire government facilities through these microgrids. And we have done a whole bunch of hotels and a few other sites that are sort of the, I'm going to skip that. This is an example of what our product looks like. We are one of the first ones to build what is called an integrated system. Microgrids traditionally have been very, very complex to develop and deploy. Primarily because they are project-based. That means you figure out what your size would be, and then you hire an engineering firm. They get different components from everywhere, and then they try to put it all together on site. And that, from our perspective, adds high cost to it and high uncertainty to it, primarily because if the people who are doing the integration work are not completely familiar with your setup or some of the unique structures you have at your campus, things might not work. So we have taken an approach where we're building these microgrids in factories. That means every single microgrid that we deploy looks exactly the same. And the reality is the reason why we did that is because we see these microgrids being deployed at literally hundreds of thousands of these sites throughout the state and throughout the US. And if we were to do that, then we have to get to a point where these are really coming off of an assembly line as opposed to really built by hand every single time. I'm not going to go too much detail into it because that's not terribly relevant at this point. But the difference really being is it's a product assembly based system that makes everything more predictable because every instance looks exactly the same. This is an example of some of the software that we have. And again, the idea behind that is that once you have these energy, if you have ever dealt with AO utilities, you know how difficult it is to get information easily on an R-to-R basis. The way we have designed the system is you would have complete control and you would have complete information on what's going on in the system, how much energy is being produced by your solar system or your renewable energy system, how much is in the battery, how much you're using at this point, how much you are likely to use, how much you have saved in terms of GHG emissions. All that information is right up at your fingertip, primarily because a lot of the stuff we do is software driven and all this information is easily available. Again, I talked a little bit about it. It's a gridscape differentiator, but it's important as you start to think about these microgrids for your campus to think about all of these points as something where it should become a part of requirement, whether again, Gridscape does it or someone else does it, that's not important. So the first point being is that you want them to be a product centric approach, primarily because you want every instance of what you're deploying to have been tested and has been working somewhere else. And that can only happen if it's an assembly line project. In our case, these manufactured projects go scale from 75 kilowatt hours to up to 9, 10 megawatt hour systems. And I want to point out here one of the comments that came out on the DSA. Fred, Ron, and Gridscape and a whole bunch of other people have been talking with Craig Rush's team here at DSA in San Diego to figure out what is the best way to get DSA to issue permit for these batteries. These batteries are quite large and they're heavy. And currently there is no real simple way to, or there's no simple solution that says, if you have this, DSA will approve that. In fact, we have gone back and forth several times and we've been told that some of the installation that has already been done may not really qualify for permitting today, primarily because the DSA has learned a lot more. And so what we're doing, we're working with Craig Rush's team, Fred and Ron and a whole bunch of other people to come up with a standardized, simple way to get DSA to approve these battery storage systems so they can be deployed easily. And we've had some really excellent calls. And Gridscape is in the process of designing a system that DSA hopefully will pre-approve it, and that can be deployed easily. And it will start out at 600 kilowatt hour systems, and then you can add multiple of those to reach whatever requirements that you need. So that's an update I wanted to give you. You want to think about any system that you deploy that runs your entire campus to be future-proof. What you don't want to do, these systems are quite expensive. They can run into multi-million dollars. And so what you don't want is you want to build something today and then 5 years from now it becomes obsolete. So by having more and more stuff in the software, what you're really doing is you are trying to make sure that these systems don't become technologically obsolete. And also as your need changes. So today you may have a need for certain load for your campus. Your load requirements will change. The tariff that's coming from the utilities will change. Climate is going to change a whole bunch of other things. The technology of the system is going to change. The battery technology is certainly going to change over the next 10 years. So what you want is you want a system that is modular and can be updated relatively quickly as we move through these changes through the system. And we at Gridscape have sort of spent a lot of time thinking about that and making sure that these systems can last for 20, 25 years very easily and stay with the technology curve that's kind of out there. The other important thing that's important is EV charging infrastructure. One of the things we're doing at San Jose City College, for example, we're putting about 35 charging stations for the usage of staff and students and perhaps even communities around the campus for using these facilities. And you want to be able to manage these EV charging infrastructure through the system, because at the end of the day, a load is a load and electricity. And as long as you're using electricity, you should be able to use the system to kind of take care of that. Again, a lot of the stuff happening in the things. This is a mobile microgrid system that we're building. This is in case you have built a certain system and you need and you have a power failure event that's going to last longer than what the system was designed for. The technologies are coming in where you can bring in mobile battery systems and attach it to your campus to provide you with additional resiliency in case of extended power failure. Again, I'm not going to get too much into it. What all it's really showing is you have a local power generation source, you have a battery installation, you have microcontrollers, and they are somewhat connected to each other. And ultimately, they are connected to the utility bill and the service panel that you have to kind of take care of all your energy needs. Not getting too much into it because that's not sort of what you do, but in case you have a fleet and then you want to take care of those fleet charging stations, they are quite complex, especially when it comes to medium and heavy duty vehicles. And you want to be able to make sure that whatever microgrid that you're putting in can take care of that as part of the overall system. What you don't want is two separate systems, one for your site and one for your EV charging needs. That makes no sense. So you want to be able to combine them. Quickly on a project, what we're doing at the San Jose City College is we're getting a solar offset of about 25-26%. Primarily, it's because the energy needs of a college campus changes. So you can design something that does 100% solar, but on the other hand, you'll be probably producing a lot of energy during the summertime when the college campus is not used to its full extent. So we try to use some mechanism to try to figure out what is the most optimal size. And again, this will depend on, I know some of you in the audience here have done an RFP for 100% solar offset, and that's perfectly reasonable. The San Jose City College did it about 26%. And so it's going to have about 2.6 kilowatt of a battery system, and then it'll have our control system, and we'll have 36 charging stations, including V2G chargers, fast chargers, and level 2 chargers. And what we're going to do is currently there's a 12 kV loop that runs throughout the campus, and we will update some of the switches to make them software driven. Therefore, we'll have ability to island some of the buildings. So again, this system is not designed to run the entire campus in case there is a power failure, and primarily because you can certainly do that, but then that reduces the amount of time that you can run on a backup power because there's sort of a limit to how much battery energy system you want to install from a cost perspective. So what we're going to do is we will have the ability to isolate some of the buildings that are critical, like the data centers and administrative centers and cafeterias and student centers. Those are critical when there's a power need, when there's a power failure, to kind of isolate them and provide the backup facility. Now, this particular project is very interesting in the sense that San Jose City College is not putting up any money up front. They have signed a 25-year PPA agreement with a entity that is providing funding for this. And what San Jose City College is doing is paying for it through whatever power is being generated by the system, and it's approximately 24 cents. And if you really think about it, San Jose City College's blended cost is approximately 28 cents today, or 26 cents today, and that will continue to rise because PG&E escalation is relatively high. And here you have a predictability as to how much it's going to increase. It's going to increase 2% every year. And therefore, over the life of the system, San Jose City College will save about $10 or $12 million. And again, saving money, as well as providing renewable energy, providing charging infrastructure, and not having any other effect on your system are sort of the goals of a local power plant or a renewable microgrid system. I'm not going to go into the city of Fontana slide, but Chabot College is very, very similar again. They already had an existing solar system, so their savings are slightly smaller. But again, there the goal was to reduce the GHG reduction further and to provide backup power apart from savings to the college. There we're doing something very unique. We're replacing all the 12 kV switches with software-driven switches. So essentially what it means is that any building at any point in time can be backed up, and you can decide which one you want to do, and you can change that mechanism depending on how long you think the power failure event is going to be. This one was possible because of some of the uniqueness that Chabot College has. Every college has a slightly different infrastructure, but these would be sort of the basic infrastructure. You have a power plant. I mean, you have the renewable energy microgrid, solar, or some other renewable energy source, energy storage, control systems, charging stations, and some sort of a loop that's powering the entire campus, and we replace some of those switches to make them more software driven. I'm not going to get into this again. We talked a little bit about it. Goal again in all of our projects is to increase reliance on renewable energy, reduce GHG emission, reduce cost, and provide backup power. That sort of is the goal, no matter how, and provide access to energy station, EV charging solutions. This is an important, I mean, you heard a lot about what Inflation Reduction Act is doing and the ITC. There always was an investment tax credit for renewable energy projects like solar and battery systems. They have become a little bit more robust, and now it's possible the incentives can be anywhere from 30% to 50%, depending on US bill content, disadvantaged communities. And the idea behind this particular one is if you're a college campus and you're not a taxable entity, you can still take advantage of that. Now, how that gets done, that mechanism is still being debated at the IRS level. We still don't have an idea of what would be the final result. But certainly the method that we use for San Jose City College, which is a PPA, a power purchase agreement, where a third party owns entity, and I have a slide on that, they can take advantage of these energy incentives that exist. California used to have SCHIP for energy storage. That has dwindled, though we expect perhaps California legislation will reinstate some of those incentives starting in 2023. it remains to be seen. This is a typical way a power purchase agreement is worked out. Actually, this is a cash purchase. So let me go to the next slide. So yeah, there are two mechanisms. Let me go back to it. There are two mechanisms. If a college or community college has the money, then they can directly work with someone like Gridscape, and we would then develop the system. We can also maintain the system for you, or you can have somebody else maintain the system. And essentially, it's a simple project that you are funding, and you get your tax incentives once IRS has figured out how to make that available to you. Another method is where someone else owns the asset. They provide funding for it. In this mode, you as a college is not putting up any money, and money is being upfronted by the financiers. They, in turn, will get someone like Gridscape to build and deploy the system and maintain it. And the agreement between the end user and the people who are financing, whether it's called ESA or PPA, it doesn't matter. They're all basically the same thing. You're essentially paying for power that is being produced and used by you. And the third-party financier then takes care of all the incentive that's out there. One big advantage of something like this is, in this mode, all the maintenance work and all of the replacement, everything is the responsibility of the party that's owning the asset and that's funding the project. When you do cash purchase, then obviously you are responsible for making sure that everything works fine. And again, I'm not going to get into too much more. This is it. So I'll stop right there and see if you have any questions. And then I think MCOR also has some slides that they want to share.
Alok, you've done an awesome job. I just have one question for you, and it's in regard to the issues that we're working through with Craig and the division of the state architect. Primarily in those discussions, there's the seismic component for the structural dynamics of the enclosure that would actually house the battery system. And then the other issue is in regard to the fire and life safety. So with that being said, on being that the lithium iron phosphate batteries are the primary load center for storing the potential energy, are they, the big issue for DSA is the fire safety. And going back to an example that they presented was the failure that they had up at one of the PG&E plants.
Right.
Can you tell us, are the batteries, how have they gone as far as the technology? How have they improved? Because there have been some, in the past where they've had issues with fires, them blowing up or whatever. How is that as it is right now with the current technology?
Good question. So I think there are some new regulations that have come in, and there are some new regulations that are coming in 2023. So there are several different answers. First of all, most of the blowing up the batteries and so on that you're seeing tends to be the NMC batteries, not the LFP batteries, because LFP batteries tend to have slightly lower thermal runaway. They are not as prone to heating up, which is really what causes the fire. The other things that we want to do is, a lot of these installations that have sort of blown up in the past did not have fire suppression, didn't have gas detection, didn't have proper ventilation because we didn't know enough about those. Now we have a much better understanding of all. So all our units have fire suppression. They have gas detection. And one of the things that we're working with Craig Rush's team now, in fact, we went back and forth on whether we can use a shipping container and put 1 megawatt or 1.3 megawatt hours of battery system in it. And after sort of going with the DSA and looking at some of the new regulations, we have realized that that's really not feasible. So the maximum that an enclosure should have at this point, based on our understanding, is 600 kilowatt hour systems. So what we're going to end up doing is not using the containers, but build a brand new system, which will be about 600 kilowatt hour systems, and then add multiple of those. So in case of San Jose City College, it's about 2.6. We may have 5 of those. We'll certainly have 5 of those for the Chabot College. And each one of those units will have, again, fire suppression, sufficient ventilation, sufficient spacing, gas detection. And so that's really, I think, is the way to think about where the whole issue of fire suppression will come. As it comes to structural issues, essentially DSA has preliminary told us that as long as we design container with certain strengths in mind and give DSA the ability to inspect where it's getting manufactured and give them all the, how it's getting welded and how it's getting manufactured, they will approve that. So that's where we are with the process. As I said, we have started putting together a design. We're giving some preliminary feedback to the IR that Craig's team is working on. By the way, Craig told us also that they are now responsible for putting all the rules and regulations regarding battery installations for all DSA jurisdictions throughout California. So this is this is actually a good development, because it means that there's one central place that we can work with, have our containers, and not just us, anyone else, be certified for DSA, so they can be installed relatively quickly. And we now really expect that to build these systems over the next 9 months to 12 months, depending on how long it takes for DSA to get that approved for us.
They will be, I know that they're working on the IR, and that will be going out pretty soon. Alok, thank you so much for your time. And I know we're kind of on our schedule still, but I want to make sure that we give the folks over at MCOR to go ahead a little bit of time to add on to what you've had. So Tony, Ken, and Mark, we'll turn the floor over to you.
Thank you, Fred. I haven't seen, I think everybody else is on. I'm Tony Ghaffari with MCOR. I'm the Senior VP of Engineering, along with Mark Fulton, who's our controls expert. The man who has seen any type of EMS system there is, from Johnson to Siemens to Distech to Delta to been around integration. Ken Miller is our Director of Automation and Integration Services. Really, the more I listen to the speakers and the audiences that are present and what they've been through since 10 o'clock, I think I want to kind of be maybe quick and to the point, but then again, I prepared a few slides, but I think it could maybe lead into maybe a future discussion, because there is so much going on around decarbonization and the grid strain and electrification and microgrid and all of that. And I'm just trying to figure out if see about maybe sharing the screen. Can I take over the screen, Fred?
Tara, I'll leave that up to you. You're the host.
If I can do a share screen, maybe I can bring my my slideshow into here. Let's see if this works.
While Tara's working on that, I think the folks need to also know that Alok, thank you so much for working around your schedule so that you could come on today and give us all that valuable information. We appreciate that. And Tony, you were kind of called on the spot. We appreciate that as well.
No worries.
And I'll be around. Just Fred, I'll be around if people have any questions for the next 15 minutes or so.
Well, see, what we're going to do, Alok, is we're going to use this as an opportunity to snag you guys again later.
Yeah, absolutely. Absolutely.
You should be able, sorry to interrupt. You should be able to share your screen. It's multiple share screens.
Okay. I don't have your screen, but I hit the share screen button. What's showing on the main screen right now?
Your name. You just.
Oh, you don't have me on the main. Okay.
Click on the share screen and you should be able to pull it up because it's on multiple participants.
So I hit the share screen button at the bottom
Uh-huh.
and. Okay, let me see if I can get this to go there.
There you go.
Awesome.
Oh, we got it. Okay, my screen is all jumbled up everywhere, but as long as you can see the main screen with my name and Ken, everybody, I think I'll just try to drive it from there.
It looks good.
It does. Okay. Let's see if I can cycle through it. You know, Alok really talked about the big picture, even though they focus on the battery aspect of the microgrid, but it's all there. And what I wanted to, I've just picked up a few topics that I wanted to discuss. Can anybody see the next slide? Okay.
Yes, sir.
So I figured I was called onto this, and you know, what is going on with the electrical grid? What that's the buzzword these days. You know, everybody's moving towards electrification. You know, we all hear about decarbonization. We all hear about reducing the carbon footprint. You know, all of a sudden natural gas is bad, and you know, we can't have natural gas boilers and domestic hot water heaters in our buildings, in our plant. You know, we've got to go with electric boilers and electric hot water heaters. Some even have you know, a compressor working in the reverse cycle for even residential or commercial use to you know, take out the cold air in your garage space and put the heat of compression in your you know, into your hot water tank to make hot water for domestic use. I mean, all of this stuff is out there. There's so much going on with all of this that it can be overwhelming. You know, I'm sure for some of the for college campuses, for the director of facilities, the engineering team, what they're mandated to do, and what the government is doing with respect to incentives and the Inflation Reduction Act and the tax credits and all of that is in front of us, and there's so much to deal with. But I wanted to just simplify things. Talk about the grid itself. What is a microgrid? Why do we need it? How does it help us? What does it mean to a college campus? And basically the reducing the carbon footprint, the carbon emission, and the future of combined heat and power plants, or cogen plants as they're known. Let me go to the next page. So the electrical grid is mostly powered by fossil fuel-based plants right now. In 2021, 12% of the total energy consumed was produced by renewables. Renewables provided 19% of that total energy generation in 2021. So they are starting to come on, right? If we talk about what the total power generation in the US, maybe worldwide was, these are US numbers, but I mean, it provided for almost 1/5 of the total energy produced. So you know, they are up and coming, and with the mandate for reduction of greenhouse gas and carbon footprint, it's just going to get more and more prevalent from now on. So the ultimate path to the decarbonization will have to address, how do we do this? How do we get a grid that is heavy into fossil fuel to basically how do you go through that transformation? Well, we would have to address the cost of new generation plants. There is the transmission and the distribution infrastructure. Alok alluded to that earlier, and how the grid has got to be so flexible that you can import and export in multiple directions. So it's not a one-way kind of a distribution anymore. And what does that mean as far as I guess maybe let's call it the cleanliness of the grid, right? Because I think one of the Trane gentlemen earlier talked about a dirty power grid, a dirty grid in Chicago area or whatnot. Well, we see that in California. The farther you get from distribution and the more inductive loads and stuff get added to the grid has more fluctuations and it has more voltage bounce, more voltage basically. I mean, if you're talking, I deal with some medium voltage sites and we see as much as 600 volts bounce in a 12 kV system, which can be significant. It can have detrimental effects on equipment, their longevity. So the transmission and distribution is obviously a big component of that. The cost and performance of energy storage, I made that as one of the components in here, and that, you know, again, Alok talked about that earlier on, because part of the resiliency of that grid, whether it's a microgrid or some form of it, you know, it'll be dependent on how well the energy storage is installed and is performing, and really what is it sized for, right? Is it sized to take care of the peak, you know, is it for peak shaving? Is it for other purposes? Is it for resiliency? And then if we are talking about microgrid, I define it in my book as generation on site, an on-site generation. If you're going to lessen your dependency on the grid, then you have to have something of your own. I mean, a microgrid, really a cogen in a way, which produces power and electricity and heat in a way. You know, when you think about your car, for instance, your car is actually a cogeneration unit, because you have a recip engine, you produce power, it goes to mechanical energy, you drive a generator, you produce electricity, it functions other aspects of the car. Within that, you have the engine jacket cooling, which goes into the radiator, and you turn that in an operator of about 190 degrees, and you get heat from it. So you've got all of these forms of energy in a car, and it's islanded because you're not tied into anybody. You got a fuel tank of gas, and away you go. So in its purest form, you know, a car fits that criteria. So what do we have to do to clean it up for a microgrid? Is there has to be some alternative near zero carbon fuels for tomorrow's cogen plants. That's going to be an essential. Now, cogens can take on, right now they're fueled, some are biomass, some are wood, some are landfill gas, some are hydrogen, some are natural gas. So they are powered in a variety of ways, depending on how they are used in an application. You know, a lot of farms in California where they burn the shells of some of these fruits and stuff, that pistachio farms or others, they turn to, that becomes the product of combustion for some of their cogen plants. Or you got the landfill gas, they turn that into a fuel for a turbine or a recip gas generator. So going to the next slide, it's the CO2 emissions, because I pulled up some information just to give you a sense of magnitude and volume and what's happening with the reason I'm talking about the cogen plant so much is because that'll be, I think, the ultimate endpoint for some of these facilities, the campuses, universities. Cogens were primarily focused on industrial applications. I mean, they produced over 81.5 gigawatt of power in 4,700 industrial plants last year. 86% of this capacity is used in industrial applications where there is a thermal demand for process. Well, college campuses have a thermal demand for process, right? You always need the heat, whether it's in the physical plant, whether you need it for heating, for domestic, for heating hot water, for pools, for other things. You know, it's like just like hospitals or other critical facilities. It's a good application. Their use is growing in commercial and institutional applications such as hospital, universities, and critical facilities. So we see benefit in producing power, on-site power, in a college campus, because one of the benefits, inherent benefit of a CHP is that you get the waste heat with it, and that's how you increase the overall efficiency of a CHP. Just in comparison, I put this on the board. A natural gas powered CHP CO2 emission is roughly 600 pounds per megawatt hours produced, which is 60% less than a marginal grid generation at nearly 1,500 pounds of CO2. A marginal grid generation is a plant that is producing the next megawatt, right? It's your EPA approved industrial power generation. You know, whether it's in California, if it's in California, it's a little less than 1,500, but if it's federal, it's about that, and it's EPA approved at this point, right? And that's amazing. I mean, look at the CO2 emission of a CHP versus an EPA approved federal or California site. And California has the cleanest of grid compared to the rest of the United States. I mean, California has the toughest mandates as far as EPA permits and so forth. But still, I think California EPA approved, it runs about 1,200. So we know that some of the manufacturers like Solar Turbine, Caterpillar, others are working on alternate fuel for their generators, and hydrogen will be the main fuel for gas and turbine generators as a long-term low to zero carbon option. And that's good news for us, because it as we move towards decarb, it gives us an option to be able to continue. It's like people were asking, okay, what's going to become of CHPs? Because we can't use natural gas, are they going to become a thing of the past? Or how do we go from there? Do we go all green generated power? Is it all going to be PV and batteries? Well, that's not going to be sustainable. That's not going to give you the resilient microgrid that you're looking for. So you'd have to excuse me, because I don't know how I don't know what the next slide is, because I just kind of put these together. But I wanted to go back to the utility. Us in California know what's become of the utility. The distribution infrastructure is a concern. I mean, all of you that have had to deal with the fires from the north all the way down to Southern California and into even San Diego area, we've all had to deal with the fires, and that to a large extent was attributed by wind events that have led to down power lines, causing fires. There are I believe multiple lawsuits going on at different stages, but we know that has been a problem. We know that power quality issues have been a problem. I talked about that earlier. As it affects sensitive electronic equipment, like the chillers and any equipment that is driven is VSD driven, whether it's your pumps, your chillers, or cooling tower fans or other things, even data centers. The power quality affects all of that, and it shortens the service life of the equipment.
Tony,
I'm sorry.
Can I interrupt real quick? Can you finish in maybe 1 minute? Because I just had the Chancellor's office get online. I want to make sure that we're respective of their time.
Sure, I'll finish. I'm almost done. We know about the PSPS event, the public service power safety.
Yes.
So they'll shut you down at a moment's notice if there is a problem, if there is a wind or other events going on. We know that the peak demands and the energy charges continue to rise. SDG&E has the honor of being the highest utility cost in the nation. So what is the resilient microgrid? A resilient microgrid could have a utility tie or could be islanded. The heart of a resilient microgrid has to be a combined heat and power plant at its base to take care of the base load. You complement that with battery storage, with on-site solar, and the solar can take on many forms. It can be a rooftop, it can be a solar carport, it can be a ground mount. But all of that together, different sources of energy combining to the cause of greater good to provide this, serve the load, use the benefit the heat to use for thermal demands. You can use a thermal storage to also lower the peak demand if you are counting on grid tie as a part of it. But in general, a TES will lower the peak demand whether you're running whether you're producing at the microgrid at the CHP level or the utility. I just threw up a picture of a PV system. This is a diagrammatic look of what a CHP looks like. You got the absorber for the cooling. You got the main benefit is the electricity and the waste heat. So you get the heat, you get the cooling, and you get the power. And I
Awesome.
just some slides that I thought might be beneficial for what we're doing for some of our clients in moving them to a microgrid.
Tony, thank you so much. I don't mean to cut you short there, but we've got we appreciate it, and we'll probably end up calling you back for a little bit more time.
Yep, no problem. Glad to do it.
Thank you
for
so
the
much.
opportunity to present.
Hoang, I know you're sitting in the corner over there waiting to get on, and we're going to turn the floor over to you for an update on the Chancellor's office goings on.
Thank you, Fred. Good afternoon, everybody. Sorry I'm a little bit tardy. Just finished the fiscal and policy webinar. Actually, I was just enjoying the presentation from MCOR, so I'll have to watch it a little bit later, but this is being recorded. With that, let me see here. What screen is this?
Awesome, huh?
Let's see here. Can you guys see my screen?
Perfect.
All right. There we go. Let's kick it off for some updates from the Chancellor's office here. Really quick, we just had a board meeting last month presenting the awards for the Board of Governors Energy Sustainability. These awards are in innovative projects, large district, medium district, small, as well as faculty student initiatives and sustainability champion. We do this once a year. Timeframe may adjust due to pandemics, but we just kicked it off, presented last month. With that, let's see here. I'd like to give some shout outs to the winners. First winner for large district is Contra Costa for their new art complex at Diablo Valley College. To you, Fred, Citrus Community College District for their educational development building at Citrus College for a medium-sized district. And for a small district, Merced CCD for their Johnson Controls partnership. For the faculty student initiative, to Santa Rosa Junior College for their Earth Day street mural, and to Terrence DeGray for sustainability champion. Like I mentioned earlier, we do send out an email once a year requesting nominations in all these categories. So keep an eye out next year. Usually around early summer, late spring, early summer for that memo. With that, a really quick housing update. I presented this a little bit earlier, so I'm just going to give you some highlights since everybody was in here listening in as on the SoCal Facilities Officers meeting instead. The memo or the process was memo was sent out earlier this month via listserv to the CEOs and CBOs. With that, you got your memo, you got your funding allocation, your DF 151, supplemental application template, total cost of ownership calculator, and the scoring rubric. One thing I want to mention is the application or the allocation was revised by Department of Finance. So take a look at that to make sure you're using the right amount in your contracts. Otherwise, it may go over. Take a look at the deadlines or the timeline for the student housing program. January 25th, 2023 is when applications are due for round 2. We've been mentioning this since legislation AB 183, AB 190 was passed, at CCFC through our various conferences and presentations. At that point in time and during the summer of 2023, it's going to go up for consideration through Department of Finance and then the legislature for approval after that. Shortly thereafter, July 3rd, 2023, we're looking at round 3 submissions from the districts for more application there. And of course, following 2024, 25, we're looking at the state budget for those applications to be reviewed and approved. As part of the package here, you're looking at something similar to your final project proposals that you submit for the capital outlay program. A couple changes or additions would be the supplemental application form. This has been revised from prior years. So it's showing more or requesting more information from the districts as a foundation for the reporting requirements that are stated in legislation. So don't skip out on that. Don't skip out on that, as we're going to need that information that will get inputted into Fusion. Another addition would be not CEQA, but SB 886, which is for CEQA exemption. This information here is going to be in the memo towards the very end. So you can either submit documents for CEQA or submit documents for a CEQA exemption on that. Also, a change would be a total cost of ownership is recommended. This is going to show you what is going to cost the district, your campus, for the lifetime of that facility. Remember, we're looking at affordable housing for the lifetime of this facility for low-income students. So the cost is going to be potential burden on your campus there. Some highlights I'd like to go over is the DF 151. Revised from prior year. Last year, you had a lot of strike dues. We made it a little bit cleaner for this year's submission. Requesting the total midpoint of construction cost. So total cost to build out this facility. There is going to be any changes from our side to do so. It will be the cost that you're submitting will be what is being requested for funding. As usual, you're going to add your project description costs or project description scope, justification for this project. Also, the supplemental application revised from last year as well includes a ton of new data metrics as part of that application. This does form the basis of your new reporting requirements. I believe in my prior presentation to this group here, there are 3 new reports. The first report is during construction, post-construction, and a new general request of information for student housing. And all that information is being built or being built into Fusion requested from the districts for that. The student housing template, similar to an FPP workbook, for those who are familiar with that. Within that workbook, there is an approval page requiring either your chancellor, president signature, and also a signature from the board of trustees for that as well. This may not align with some districts who have board meetings after the deadline due date. So you can submit your application on January 25th. Follow up with the signature sheet for that. Within that email you submit to our office, just state that the approval page is coming after signature. On the work template as well, there is a quantities and unit cost tab. We call it on that estimate tab. That will be your foundation to get to the JCAF 32 midpoint cost, which is what you'll be entering on the DF 151. JCAF 31 as well, your building space. There on that tab, there is a highlighted square stating to get costs either from the state guidelines for like office space or things of that nature. And if you're working with a cost estimator or architect, get costs from them for your 900 series, your student housing, excuse me, apartment series for that. And I also include your equipment costs as well. There isn't the ability to come back and ask for equipment afterwards. This is a one-shot application to request for it all. One thing to note, because there are some new people in this field, is that this template is workable, manageable. So it's not fixed. I've been having questions about certain cells not linking to other cells. You have the ability to relink, readjust the estimate tab to relink to things on the JCAF 31. So that way you get to bring costs over and shift it around as part of this template. Also part of the email is the scoring rubric. The prescribed section of the rubric is the basis from legislation from SB 169, AB 183, AB 190. So that's the prescribed section for those costs. The administrative side is something that our office has worked on, following the vision for success as that basis to score on that section. So for the review process, we're looking at round 2 and round 3. The student housing unit will review those applications and score them. These applications will be shared with the Department of Finance and whole, and after which point will be shared with the California legislature. One thing to share is the legislature does have final authority on who will get approved, and those applications that get approved will be in the annual budget. Just to note really quick, the scoring of these projects, dissimilar to FPP, where when it goes into Fusion, you'll see scores eventually for some metrics, but not all metrics. Some of those metrics, the scores will come out afterwards as they need to be compared with all the other applications. It's a twist, but that's the way it's written in legislation. So it is something that you'll have to be aware of as part of that. Submit all your applications to student housing at CCCCO.edu. That's the new email address to send everything forward to, as we're still working on the student housing unit right now. Some due dates for everybody. For those that are behind, space inventory, schedule maintenance, energy usage calculator, we're already due. Please reach out to either Drew Bott or Brian Turner for that, stating that you need an extension, as they're probably already aware that you will do in regards to that. Instructional support workbook coming soon as a requirement, and of course, student housing applications next month. And with that, here's the contact information for those different categories or programs as well. And with that, any questions?
Hoang, as always, thank you very much for accommodating our time. And I know you have a very busy day. We sincerely appreciate it.
No, not at all. Thank you for having me. It's always a pleasure presenting to NorCal and SoCal facilities officers.
And congratulations to Terrence. I think we should all give him a hand.
Congratulations to all.
All
Please
right.
submit your nominations next year. Thank you.
Does anybody have any questions for Hoang while he's still on? Seeing that, you see, Hoang, that's how thorough you are. You're able to answer everybody's questions on the fly. That is awesome.
I'm pretty sure I'll get the emails.
I bet you will.
All right.
All right,
Thank you.
folks. Ron, do we have the CEC folks on?
Yes, we do. I see Daniel. Yeah, I've seen a few of them on here.
Hi there.
Awesome.
Can you hear me okay?
We can. Daniel, it's all yours.
All right. Well, thanks for having me. I just want to introduce that I have Britt Kelsey as well joining me today. And yeah, I just wanted to say, thank you to the 10 community college districts that did comply for year 2021. I know we've been giving kudos for every presentation. Last time we saw you guys was when it was the conference here in Sacramento at the convention center. So that was nice to see everyone. We've been presenting to the CFO and everybody for this entire year. So still working on, the rest of you CCDs. So we sent out a letter around Thanksgiving time. I'm gonna go ahead and share my screen. So this letter was sent out, like I said, around Thanksgiving time, and it went to a lot of CBOs and CFOs for the 63 community college districts that haven't sent us their energy usage reporting for 2021. So I wanted to say, we've already got some responses back. So thank you for those who have responded. I know there's a lot of questions and things. And, the newsletter that was just sent out, we have obviously there was a blurb in there about Ron and Lisa and what they do. So I just want to say thanks to them for the help that they've been providing to the community college districts. And I just want to introduce Lisa just to kind of say, have her give a little spiel about, what they're doing and how they can help you. Lisa, you there?
Yeah, thanks. So yes, if you got that letter, and there have been a lot of districts that have already reached out to me, with the partnership ending, it's getting a little tricky for us to help, but we still can help you get set up. So you'll just make a portfolio manager account and then I can help with that process. But if you need any help with data entry, you'll have to contract that through Ron and FPPS. But right now, through the end of this year, all of my time helping is charged to the partnership. So it's free of charge to districts. So please reach out and try to be in compliance.
Yeah, thank you.
Yeah.
Thank you. Yeah, if anybody didn't receive that letter for any reason, I know I sent out some before Thanksgiving, which a lot of people are usually taking off. So if you didn't get it, I'll personally send you a copy. So just let me know. You can send it this benchmarkingenergy.ca.gov or mine, which is Daniel.Johnson, same email address. So just let me know. And yeah, we're looking forward to hearing from you and helping you as well. So with that, that's all I have. Anything else from you, Ron?
Yes, Daniel, I know that we have these monthly update meetings with you and with Hoang and I have these meetings with you, but you see a lot of talk about the in these presentations today and these discussions about the possibility of the Inflation Reduction Act money coming our way. And I think it's always good that they hear it from you about what that amount is. And maybe if you could talk about that a little bit and kind of let us know basically where we might be able to get information as community colleges to
Sure.
To find out what you guys are planning on, how you're planning on splitting that money up and how we might be able to have an opportunity to get to it.
Sure. I would say that the process is still going to remain the same because obviously it takes months to draft grant funding opportunity, and we're going to do our largest hiring we've ever done. There's only 600 people in the agency right now, and it's going to expand to, I think, another 250 people are going to get hired from this additional funding that we're getting, somewhere around $8 billion, I believe. So it's a huge shift for the commission itself as well. And we have a funding page that just as the funding comes out, and you can sign up to the listserv for funding. So it'll send you an email personally when the new things drop down. I was looking at it recently, and it was a lot of like technical things, but once stuff comes out that would benefit colleges, you'd be aware of it through the listserv. So I can put the listserv in the chat after this presentation. I think that's the easiest way to be in the know. Just make sure to open it, because it's, it could get lost, but it is up from our listserv from funding. So I would say that's the best way right now.
And I think one other thing that I think folks might want to hear about is the compliance with AB 802, and the benchmarking is going to be important in being able to be eligible for these funds. If you could talk about that a second.
Sure. Yeah. I mean, it's still, it would have to be written into a grant. So it doesn't currently exist as a requirement, like it wasn't a requirement for, what was the school funding called? The one that did all the retrofits. Anyhow,
Prop 39.
Prop 39. So it wasn't written into Prop 39, and it doesn't currently exist in anything right now, but it technically is possible in the future, where you'd have to be complying with state laws in order to be eligible. And so, I can't say if it does exist right now, or it doesn't exist right now, and it would have to be written into a grant. So it's still kind of a thing, but just to, further give incentive at least to be complying with state laws. You wouldn't want to be caught, off guard and then have to do extra requirements and maybe miss a window that would be important. So, yeah.
All right. Well, thank you.
Yeah, definitely.
Daniel, thank you very much. We always look forward to your update. And honestly, speaking on behalf of the group, our goal is to be in compliance and help you guys out with what you need whenever we can. So,
all right. Thank you.
I know somebody's already talked about the wonderful job that Lisa and Ron are doing. I have to concur with that. Lisa helped to get us online, and now everything's reporting. She's our hero. So for those of you that have not gotten all that stuff taken care of, make sure that you reach out to her. She does a wonderful job.
Yeah, sure does. All right. Thank you.
And then what we're going to do, Daniel, is you're on the the perpetual invite.
You're right. That's fine.
Other duties as assigned.
No,
I love those.
Yeah. All right. Thank you.
You have a wonderful day.
All right. Thanks.
All right, folks. Next up on the list is Rebekah, and I know that she's been just waiting behind the shadows to give her legislative update. Rebekah, the floor is all yours.
Hi, everybody. Can you hear me okay, Fred?
Yep, you look awesome and your voice is coming through A1.
Excellent. Okay. So I am the legislative advocate for Community College Facility Coalition, and I don't have a fancy PowerPoint. I just like to kind of speak from the heart to you all. I'm going to talk about a couple of things going on in Sacramento, and then looking forward into 2023, sort of where we're heading on a number of policy issues. And this is similar to the update that I gave recently at the ACBO Facilities Task Force. So be patient with me if you've already heard that, but there is some additional new information on some of these items since we last had that meeting and talked there. So first off, I want to talk a little bit about the election that we just had in November and impacts here in the state. We had a number of local bonds that were on the ballot. There were 100 K-14 bonds worth $22.7 billion on the ballot. So my colleagues are in the process of finalizing a list of those bond elections. I do know that it looks like there's about 7 community college bonds that are passing. Some of you who are, who have one of those bonds that might be on the bubble with the votes, because there were a couple that were right there at 55%, you're going to have a better status on some of those than I will. But congratulations to those of you who have successfully passed a bond. That's very exciting and lots of good work to come from that. The elections are certified by counties today, and then on December 16th, the state will be certifying the elections. So reach out to me after the 16th if you want a list of all of the local bonds for K through 14, and I'll provide that to you. As far as a leadership in the legislature, this is a once every 10 years cycle this year. As a result of the census and redistricting, we have about a third of the legislators who are changing. So brand new, coming into the building for the first time. They don't know where the bathroom is. They don't know what their job is. And so this really shifts the dynamics in Sacramento on how we educate those folks, how we bring them along on our issues, how we convince them to care about community college facilities. Spoiler, it's not usually their top issue. So there's a lot of education that has to be done with those folks to bring them along. The Democratic supermajority is maintained in both houses of the legislature, so that shift does not change. That doesn't shift at all. But one big transition that will be taking place is legislative leadership in the assembly. So the assembly speaker, this is the top assembly member. There has been a battle over who will have that position. And Robert Rivas, who's an assembly member from Hollister, so kind of Central Coast area, inland a little bit, he made a run at that position back in May, and Assembly Member Rendon, who is the current speaker, kind of fended that off, deferred it, said, we'll make that decision in the future. Well, they have reached an agreement that has now been ratified by the legislature for a transition plan. So Assembly Member Rendon will continue in that position until June 30th of 2023, and then Robert Rivas will take over. This is a historic transition because we've never had somebody outside of one of our major population centers, think San Francisco or Los Angeles, in that position. And so he will bring a very different perspective to that role. It remains to be seen how it'll affect the politics, the king-making, the issues of the day, but it's going to be a real transition for that body. I will say kind of my analysis is that Assemblymember Rendon is leaving with his legacy intact. He didn't get pushed out by some upstart. It's on his terms, and he'll be there to help show the new members where the bathroom is, and it'll be like kindergarten, and you've got a very experienced teacher at the helm for the first 6 months in 2023. We are waiting to find out who our new Assembly Higher Education Committee chair will be. So they take on a lot of the issues in the facilities arena. And then as well, our Senate Education Committee chair, both the folks who had that role previously decided not to continue in the legislature. So we're looking for folks to take those positions. Thinking about the budget, and this connects to student housing, this connects to possible capital outlay money and what's going on in that arena. We are seeing the framework for budget negotiations starting to take place for 2023. The Legislative Analyst's Office recently released a report saying we think the deficit's going to be about $24 billion. And that $24 billion is not related to Prop 98. So this is outside of Prop 98, $24 billion problem. That $24 billion problem does not assume a recession scenario. Well, why is that? Legislative Analyst's Office, we have to remember who they represent, who they work for. They work for the legislature. Legislators represent individual communities and constituents, and they've all got their programs that they love. They don't want to be in a position where they're cutting programs prematurely if a terrible budget situation does not materialize, right? So LAO is saying, don't start making cuts and assume a recession. Let's let this play out. We have a number of months before the ink needs to dry on that budget document, and the governor and the legislature need to decide on the size of what that budget deficit or problem might be. What's interesting in the LAO's analysis is that they're talking about, when they looked at Prop 98, they said, well, Prop 98, education, K-14, operational dollars, they're going to be pretty well protected in this next budget cycle. Obviously, we've got constitutional funding formula commitments. But on top of that, LAO is saying we can probably afford a COLA pretty close to what the statutory COLA would be, which is north of 8%. So we haven't had a COLA that big since 1979. So education's not doing too bad. And here's a number that is pretty shocking. Since 2019, the proposition minimum guarantee grew by over $31 billion. And so as we go into next year, LAO is saying, well, we think it's going to decrease from last budget year by about $2 billion, but the gains that have been made since 2019 far exceed the decrease that we might see going into 23-24. Not all is rosy though, right? There's a $24 billion budget problem. What gives? The problem is on the non-Prop 98 side of the budget. So, health, human services, these other competing interests, important programs for folks in California. And the tension that gets set up there is folks on the non-98 side of the budget look at education and they go, you guys are getting all the money. This is not fair. And by the way, don't come to us and ask us for more because you're already getting a significant chunk when we're having to make cuts on our side of the budget. So the reason that I'm going through all of this is to just bear in mind that as we go into this next budget cycle, we are going to need to gear up and be prepared to advocate for the promises that have been made to us. And in particular, I'm talking about the student housing money. So we've got another $750 million that's been promised for 23-24 for the 3 higher education segments. We know that housing and homelessness is a big priority in the state of California. But we also need to go into this with eyes open and understand that the legislature and the governor may very well be in a position where they're having to look for things to cut. LAO has said, legislature, be smart about this. If you've made a promise to a program, but those dollars have not yet been encumbered, you may need to start thinking about clawing those back and using them for other budget purposes, i.e. ongoing programs where we've got entitlements. I put student housing in that category, right? It was a one-time expenditure that was a promise made to us in a very, very incredible budget year. Now, the thing that gives me a little bit of hope is that expenditure was tied to the GAN limit. And what we don't know is we haven't been able to look under the hood and really understand, well, how many GAN limit solutions payments need to be maintained or made in 23-24, and what types of expenditures will then be prioritized out of those commitments. So we've got something to work with. Student housing is absolutely connected to one of the state's top priorities. We're all very excited about the program and the applications that are going in January. Do not take from this update, Rebekah says we're losing all of our student housing money. What you should take from this update is Rebekah is prepared to fight for that money and to advocate for that money on behalf of our districts. And so that we can get what's been promised to us. And so it'll take a little bit of work in this budget process, probably. Governor will release his budget January 10. So once he does that, we'll kind of know the parameters that we're working in. Legislative Analyst's Office is always a little bit more optimistic about what revenues we have to play with. Governor is always a little bit more conservative, and we'll see where we end up, right? I would not panic if we don't see the 750 million in the January 10 budget, because it's much easier to add at the May revision than it is to take away from the governor's January budget, at least politically speaking. But we've got that tension, the 998, the non-education folks looking at education going, you guys always get everything. And that is absolutely going to be a factor in budget negotiations next year. Another takeaway from all of this is that we are already hearing that legislators are being told, do not introduce bills that cost money. So remember, we've got a budget process, but then we've also got a policy bill process. And sometimes, there can be a cost associated with a bill that moves through the policy bill process. Well, they're being told across the board, do not introduce bills that cost money because you're not going to get what you want. This connects to state school bond, right? So we don't have any bond authority left for new projects really in the capital outlay program. And on the K-12 side as well, they are out of their school facility program bond money. If you submit an application today, there's no funding for that project on the K-12 side either. K-12 does have about $3 billion in general fund funding commitments over the next 2 years that they're expecting. So similar to our student housing money and that dynamic that's playing out there. But because we don't know if that money will come to fruition, it could actually increase pressure for a 2024 bond as a guaranteed source for facilities funding. So we're starting some of that preliminary work, which is exploring introduction of a bond bill for 2024 in the 2023 calendar year. So early next year to get the conversation going, to get members up to speed so that they understand how important this is, building the coalition, bringing partners on, finding an author. We don't have Assemblymember O'Donnell, who's really been our champion on school facilities issues for the last 6-7 years. And we've got a number of questions about what does the governor want? What does the administration want? What do voters want? What do they understand to be the priority? So there's a lot here in the landscape that goes into kind of building that bond. There was one bond bill that was introduced on Monday, which is when the new legislative session gavelled in. That was SB 28 from Senator Glazer, and he's introducing a $15.5 billion K through university bond. So this is kind of setting up the paths that we had in the last year on the Senate side. Folks there wanting to include UC, CSU in the bond, and think of that as just putting down a marker for negotiations. There are provisions in his newly introduced bond bill that make some program changes on the K-12 side. So the K-12 folks are not enamored with that approach. It is very similar to the failed Prop 13 from March of 2020. But these are conversations that are going to take place over the next year plus, working towards a possible 2024 bond. Last thing that I want to mention in this regard is just on student housing. We've got that round of applications that opens up in January that Hoang spoke about. That's what the 750 million would be tied to. For future application rounds, i.e. July 2023 applications, there is no funding source that's been identified for student housing. And given kind of the budget picture of where we're at, that would be a conversation that I expect it may not go great. So we'll see what happens. We never know what's going to happen with revenues in the state. We've had a crazy yo-yoing back and forth over the last couple of years. Is it a $54 billion deficit? No, it's a $75 billion surplus and back and forth. So things have been wild. But just to note that 750 million is the last statutory commitment for student housing. And then I want to wrap by letting folks know a couple of legislative issues. I believe I've talked with this group about SB 1144, which was Senator Wiener's bill on water quality assessments and lead pipe replacement. That was one where CCFC had concerns, but we didn't take a formal opposed position. We did provide some cost information to policymakers and to the governor. That was ultimately vetoed. So I consider that to be a win, that there was a lot in that bill that would have made it very complicated and difficult to implement. I don't think that the issue of water quality goes away, but we were excited to see that bill vetoed. Second thing that I want to just mention as I wrap up is I am looking to talk to folks who have done or are very interested in doing progressive design build. There are a couple of things happening out there in the landscape. And there's a relationship between legislation that was passed last year for K-12 and water districts and potential impacts on community colleges that are doing progressive design build. It's all pretty nitty gritty in the statutory details, but I'd love to just chat with you if you or your district has done a progressive design build project and kind of get your perspective on some things. So feel free to reach out to me. I'll put my email in the chat. And with that, Fred, I'll see if there are any questions or if there's anything that I didn't touch on that folks do want me to talk a little bit about. But we're getting ready for a fun and exciting and wild year in 2023 with all the brand new kindergartners coming in to find their desks.
Well, Rebekah, as always, thank you so much for joining us today. And thank you to you and your team over at MWH for all the stuff that you help us with and all the support that we get all the time. We appreciate it very, very much. Does anybody have any further questions for Rebekah? And you want to hear her say, oh, yes, there's going to be a facilities bond in 2024, but she's not going to say that.
I'm very optimistic, Fred.
There you go. So just real quick, you know, in the arguments up there regarding the education side relating back to Prop 98, and how do you think the psychology works out with supporting a school bond in 2024?
You know, it's a really interesting question, Fred. One thing that we see consistently over time is that voters support education. So if we're talking about psychology, I absolutely think that it affected Prop 13 and the March 2020 bond, right? Folks had a hard time understanding that that bond wouldn't directly impact their own pocketbooks. And when the stock market tanked in February of 2020, folks who had on paper lost a lot in their retirement accounts didn't feel like they could open up their personal wallets to support something like a state bond. The reason that that was such a complicated and convoluted sort of analysis at that time was there was language in that bond that talked about the ability of K-12 districts to update their local bonding capacity and increase it. So we could no longer make the argument that that bond does not increase your taxes. And voters for the last 15 out of 17 bonds statewide have passed them. Voters are typically very supportive of education. I actually think about education bonds as a get out the vote drive more than anything because we have so much support for them. But it's that convoluted mixed messages that happened in Prop 13 that really affected us. So moving forward with the 2024 bond, we want it to be clean. We don't want it to include those things that send mixed messages to voters, that give taxpayer groups that are typically anti-bond something to sink their teeth into. We want to keep it clean because remember, a state bond doesn't increase anybody's local taxes. Instead, what it does is it says voters are prioritizing tax revenue that's already going to the state, that was already going to go there for educational purposes and paying debt service. So Fred, the psychology question is a really good one. And even in a recession, right? That's the best time to do public infrastructure, right? You get people to work, you get people in the community, it's economic development. And so those types of messages can be very successful.
That's interesting. And then, okay, so Prop 98, what was the date on that one again? Was that late 80s?
Yeah, 7th. Yeah, here, I'll Google it while we're talking.
Something like that. And I know that, I'm pretty sure it was. And if you think about that, that was right at the transition from a recession and the interest rates were exceptionally high. Just something to think about. So no questions for Rebekah. Again, we sincerely thank you and we'll let you go. Ron, I know you want to take just a moment to talk about the things that we have going on with the partnership and the transitioning and the sunsetting and all that kind of good stuff. Some folks are aware of it, some folks are not. So with that being said, Ron, I'll turn it over to you and Lisa.
All right. Well, thank you, Fred. Sure. On the partnership piece, it is transitioning to a what they call a HEPA higher education energy program that is being implemented by which has been required to be implemented by the Public Utilities Commission. So it has been a change that I think is going to be a little bit different for everyone, but it's a little bit different program. We have started some meetings with the HEAP program folks, which is called Clear Result. And we have these discussions with them in order with stakeholders in mind to at least start formulating an idea of how they're going to do their implementation. They have started reaching out to some of your districts. So it would behoove you to take an opportunity to see what they have to offer. In the interim, I've made a commitment to Hoang and Chancellor's office and to community colleges that we will continue to support the website in some way. We will continue to support you guys as far as getting you set up in portfolio manager, at least until the end of this year, if we can just get you started. But later on, we'll have to have some sort of contract with you in order to go ahead and complete the process. But we are more than happy to try to get you somewhat in compliance with the commission so that we can get that at least done for you. And then I think as far as support, though, we'll continue to support the SCFO, the NorCal group, and also the Energy Resource and Sustainability, which is called Partnership now. It'll probably be called Program, but we'll continue to support those committees. And I'll continue to support the committees that I'm currently on now until we figure out how things are going to go with Clear Result. Okay, so with that, and then also I wanted to make some clarifications from today. I think we heard a lot of great stuff today, especially about gridscapes and from even MCOR and some of the other programs that are out there. But I also want to let everybody know that Trane, that company, is in our college buys program. And in college buys, there is a way to purchase both labor and material through that to have some of your projects completed. And as far as the gridscapes and the battery storage is concerned, the work that we've been continually doing with DSA, I do intend to help and support Fred on that. Fred, as you know, is the community college representative on the DSA advisory board. So I think, as we reach out to him and other aspects of it and have concerns with any of this battery storage, I think we want to hear about that so that we can at least point the views in that direction. The utilities have some ideas with EV charging stations and some things that we want to get started there. We will continue to support the utilities in that arena as well when they're reaching out to DSA. And then the other clarification was with MCOR, when they made some presentation that sounded like they were doing some bashing of our utilities. And I kind of reminded them that, they do support and sponsor this program, this meeting, this NorCal, whether it be NorCal or SoCal in some way through my contract with them. And so they have been very great, I think, to work with across the state. And I think when MCOR was talking about what they were doing is they're talking about capacity issues, dealing with across the state, dealing with electrification, and whether we'll have electrification to be able to do all of those things that is being asked of us at this point. So I think that was a good presentation, but also at the same time, when they're talking about there was only about 12% of clean energy on the grid, I think he was not talking about California. California, there is like 30 to 40% of green energy that is going to the grid at any given time. So I think some of those things might seem misleading in a way. But I think, because California has been a leader in cleaning up the energy for that use. So I just wanted to try to make some of those clarifications as we go along. And Lisa Hanneman, have you got anything else you'd like to add to this?
No, I think you covered everything, Ron, perfectly on what's going on. The only other thing I would say is that, you know, the goal at our next SCFO is to have Clear Result come in and do a small presentation, a few minutes, just kind of talking about what the energy efficiency opportunities will be from them going forward. So we look forward to that. And then, you know, if there is in the future a presentation, Fred, that we think would be important, you know, because there is a lot of talk about electrification on what are the utilities doing on the distribution and transmission side of things, you know, to accommodate for electrification, because we know there's so many things with the legislature that are out there right now that are growing around, you know, GHG reduction. You know, that's something that we can offer to do if that would be helpful.
Lisa, we'll be bringing all of those items back, and a lot of it is just to make sure that everybody gets a complete education on what are the variables that are entailed in that. What is the truth? You know, because a lot of the numbers that are out there, they don't necessarily speak the truth for our locality. So for instance, I think the numbers that MCOR was talking about was from coast to coast, and that's not from the west coast of the Salton Sea to the east coast of it. It's from the west coast of California to the east coast of Massachusetts. I think that's where the clean energy number came from. So included in there would be states like West Virginia, which burns a lot of coal and all that other stuff. And that's how it kind of got mixed up. But we will be bringing all of those things back. You know, there was one, I think it was on the Trane slide and or in their PowerPoint, and it talked about the building envelope. That truly is number one, because the bottom line, in order to get to greenhouse reduction and the total carbon footprint, that means that the building has to be efficient. And that means you're limiting the rate of thermal transfer, because that's what all of the new stuff is going to be for. They're trying to move energy from one side to the other. And depending on which season you're in, you want to limit that transfer in order to reduce the amount of PV that you have to have, which will be included in the new building code. You have to make the building efficient. And a lot of folks don't understand that California building code is a minimum requirement. If you add and put a little bit of money into your new building and you make that resiliency in the building envelope, you're doing nothing but helping the state, helping yourself, reducing energy costs, and you're actually reducing your construction costs as well, seeing as how the generation will be included in that. And if you can reduce that, there's a lot of money that's in there. People need to realize that. So we'll be bringing back more stuff like that as well. With all of that being said, Ron, you and Tara have done a phenomenal job in supporting us. And you know, I'm really sad to see this so-called transitioning thing and the sunsetting of the partnership. Many of us have been around for a number of years and have seen it grow. Lisa, you've seen more than anyone, because I think you've been on there from the very beginning. And to see all of those challenges overcome and all of the great things that you guys were able to do is truly monumental. And Fred Harris would be very, very proud of you. And to see that kind of coming to an end, I won't say that, but moving on into something different. All the folks that are on the call today, and for the folks that aren't, they probably don't realize that the utilities are not going to have the amount of role that they had in there before. And that's why we need to put a lot of time in with the new folks that are coming on board, with the heap of program that they'll be delivering. And in order to see a complete, clear result, we're going to have to coach them a little bit too and work together as a team. So Ron, you and Tara and Lisa and all of the utilities, we as the community college side owe you a debt of gratitude for all the stuff that you've done for the system and for all of us. Because I know at my campus, we would have never been able to save, well, now it's almost up to 3.5 million kilowatt hours. And hey, that's totally awesome. And it's because of all the good stuff that you guys did to help us.
Thank you. I also would like to sing some gratitude toward your way, Fred, for the work that you guys do, Michelle and Terrence up north. It's amazing to have this kind of a forum to be able to share with facilities folks that are across the state. I mean, we've seen up to 68 people on this call today, and they come from as far north as the Redwoods to all the way south to southwestern down. It's amazing to be able to see that particular participation in just one meeting. And it's good that we all are able to share. So thank you, Fred, Michelle, actually, and Terrence for your great hard work.
Well, folks, we're at the end of our program, and I know we still have some People's Choice or open forum. If there's anything that anybody would like to say, raise your hand or speak up. Now's your time. And if there aren't any questions or anything, if you have any great ideas for programs that you'd like to see in the future, educational needs, any type of stuff like that, feel free to reach out to any one of us, drop us an email, send Ron a call. I'll give you his home address and personal cell number and all that kind of good stuff. You can bug him anytime. He takes calls at 2 a.m.
Yep, I'll do all of that.
Ron, I think you're clear.
All right, I'm clear. Thank you.
All right, so hey, everyone, thanks for joining us today. Go get some
think
lunch.
Ruben held up his hand. I'm not sure. Ruben?
Did he?
Yep.
Ruben's been quiet all day.
I know.
How you doing, Ruben?
I'm doing great. How about you?
Good.
No, I was just saying goodbye. Thank you. Appreciate it.
All right. Thank you. All right.
Folks, have a wonderful day, and we'll see you next time.
Thank you all.